Every great change begins with an idea. Bold enough to question the present and visionary enough to imagine the future. Seeing the bigger picture, a group of scientists came together to share their vision and revolutionary ideas. In 2002, they set out to create more than just a conference. They built a global community of thinkers, innovators, and change makers, united by one mission: to face challenges and call for action.
The SDEWES conference originated in Dubrovnik, a city that flourished at the crossroads of empires by embracing lateral thinking and a broad perspective. Inspired by this approach, we set out to address the challenges of sustainable development across energy, water, and environment systems.
From the very beginning, SDEWES stood out, ahead of its time, a pioneer in connecting key issues as part of the bigger picture. While sustainability was still a distant idea to the world, conference was already exploring real solutions. SDEWES has always been more than just a scientific conference. It is about collaboration, vision, and determination to shape a better future. To expand across regions, to encourage the integration of energy, water, and the environment, economy, and society as one interconnected system.
I love SDEWES for its multidisciplinary spirit. It shapes global climate policy and often presents mitigation solutions beyond the IPCC. Coming from South and Eastern Europe, for me, SDEWES has been an eye-opener and a boost to scientific standards.
Since its first conference, SDEWES has grown into a global platform, meeting ground for the brightest minds tackling real-world challenges, the ones our future depends on. Climate change, energy transition, and sustainable development were discussed at SDEWES long before they became political headlines. And from the beginning, it has encouraged policymakers and industry leaders to face challenges head-on.
Scientists and researchers have increasing responsibilities to connect solutions and systems make an impact for a safer climate future. From Asia-Pacific to Africa, from Europe to the Americas, there is great potential to continue to collaborate in teamwork and to realize the possibilities that there are to envision, enable, and advance together to realize these and opportunities.
The past decade has been the 10 warmest years on record. In 2024, global temperature was about 1.55 degrees Celsius warmer than the pre-industrial average. Every fraction of a degree matters, increasing risks, damages, and costs to society. Greenhouse gases continue to rise, reaching record levels. The oceans absorb 90% of this excess heat, warming waters, disrupting weather, and threatening marine life. Glaciers are melting, ecosystems are degrading, and our resilience is being tested as never before.
Closing the ozone layer and solving the global warming problem are often compared, but the value chains behind are completely different. The transformation of the energy system are completely different. Those who produce and install photovoltaic and wind power systems are not the same that operate the global fossil system today. The latter will disappear, and that is the battle we need to continue to fight.
How can we use the benefits of civilization in the most ecological way? How do we reduce resource dependency? Today, more than ever, science must inform and demand action. At SDEWES, participants from around the world present their research, proving that sustainability is not a local issue, but a global mission. The goal is always the same: to connect ideas across borders and disciplines, and to inspire solutions that work in practice.
They create a unique space where science meets local challenges, helping shape policies, inspire innovation, and strengthen regional capacity for climate action. From Rio de Janeiro, Sao Paulo, Buenos Aires, Viña del Mar, and now Cartagena, SDEWES empowers Latin American voices in the global sustainability dialogue, building a more just, resilient, and low-carbon future for all.
The International Scientific Committee is the backbone of the SDEWES conference, with its members playing vital roles. Half are ranked among the top 2% of the world's most cited scientists, according to Stanford University. Beyond the conference, SDEWES is a scientific family that continues to grow. A place where young researchers meet mentors, where collaboration becomes action, where friendships cross continents. The quality of discussion sparks new approaches, and the diversity of ideas enriches every perspective, a legacy built from the very beginning.
I happened to come to the first SDEWES conference in Dubrovnik already in 2002, and I found it so fascinating that I have been coming back ever since. I think that the cross-disciplinarity with energy, environment and water is really good. I think it's one of the best contributions to how we as scientists can develop how to do the green transition.
The impact of SDEWES is measurable and profound. Over the years, it has brought together thousands of experts and published several thousands of contributions shaping global energy and environmental policy. The energy transition is gaining momentum. Renewables are becoming a leading source of electricity, while the electrification of industry, transport and heating is accelerating. And today, more and more countries are recognizing the power of integrated and smart energy systems.
China's green energy has taken off like a rocket during the past few years. May the SDEWES conference spark fresh ideas, new friendship, shared action, so we all move faster toward a net zero future.
The energy transition is vital for Morocco and Africa. It's not just about sustainability. It's about development, resilience, and future prosperity. That's why I believe it was essential to bring SDEWES to Morocco and to host the first ever African edition in Saidia, creating a platform for dialogue, innovation, and cooperation across our continent.
A global transition to 100% renewable energy is not a dream. It is possible, affordable, and within reach. Clean energy, sustainable cities, safe water, thriving communities. These are not distant goals, but interconnected solutions to be achieved. And the true power of SDEWES is to be the meeting place for those determined to make it happen.
I'm deeply proud to have been in the origin and involved along the years in the SDEWES community. It has started in Dubrovnik and now puts together researchers and scientists from North, South, East and West in the 5 continents, involve more than 70 countries. Congratulations to SDEWES.
The spirit of SDEWES is stronger than ever. From a pioneering idea to a global community, it has become a driver of innovation looking ahead to the next decades of sustainable development. This is a long-distance race, but never a single discipline. It is a system of interconnectedness between energy and water, environment and climate, research and practice, knowledge and action, vision and mission.
The world resonated with our vision. Today, SDEWES is a vibrant scientific community expanding globally and shaping the best solutions for the sustainable future.
The story of SDEWES is not just one of achievement, but of continuous transformation, celebrating a symbolic milestone, years of vision, growth, and influence. It continues to challenge, question, and inspire, from Dubrovnik to the world.
Good morning, distinguished guests, esteemed colleagues, and future leaders in sustainability. On behalf of the local organizing committee, it's my great pleasure to welcome you all on this 20th Conference on Sustainable Development of Energy, Water, Environment Systems, SDEWES 2025. We are thrilled to have you here in the historic and beautiful city of Dubrovnik, and I hope that you didn't come here as a tourist, but as a scientist with an open mind and open hearts for new ideas, for new friendships, for new collaboration, because it's our mission to continue to foster a deeper understanding of how we can achieve a sustainable future. Our focus is on the crucial task on decoupling the economic growth from the consumption of planet's finite resources, paving the way for a knowledge-based economy. This conference, as you could see, is a unique platform that brings together a diverse group of researchers, policymakers, and industry leaders from around the world. It's a place for vibrant discussion, sharing groundbreaking ideas, and forging new collaborations. We encourage you to engage with one another, challenge existing paradigms, and contribute to the collective effort of building a more sustainable and equitable world for generations to come. Welcome to SDEWES 2025. Let the exchange of ideas begin. So, it's my great pleasure and honor, and please join me in welcoming our conference secretary, Professor Zvonimir Guzovic, who will deliver the opening welcome address. Professor Guzovic, please. Professor Guzovic is here with us from the second conference, and he's a member of scientific committee that brings really a lot to the conference. So, please.
Dear colleagues, friends, ladies and gentlemen, it is my great pleasure and honor to welcome all of you to the 20th Jubilee Conference on Sustainable Development of Energy, Water, and Environment System, SDEWES. The SDEWES family is constantly growing. In addition to the traditional Dubrovnik SDEWES conference since 2002, we also have a series of Southeast Europe conference since 2014, Latin American conference since 2018, Asia Pacific conference since 2020, and from this year, African conference. Also, the number of participants from the first to the 20th conference increased tenfold, from 60 to 600 participants. This is excellent and points to the importance of SDEWES conferences, especially when we remember the recent catastrophic phenomena that are direct consequence of global warming, numerous of major fires, hurricanes, major floods on one side, and major droughts on the other side of the world, problems with warm water of rivers and the sea, etc. The main aim of the COP29 conference held in Baku, Azerbaijan in November last year was to deliver a new significantly increased climate finance goal, setting a minimum of $300 billion USA dollars annually by 2035 for developing countries to advance climate action. Scientific researchers show that global warming and its effects are happening faster than expected. Therefore, at the celebration of the 8th anniversary of the founding of the United Nations last month, the UN General Assembly called on member states to submit update climate plans to renew global moment in the fight against climate change. Unfortunately, at the same time, could be heard that renewable energy sources and climate change are a scam. Also, that the prediction of the UN and other institutions were wrong, etc. Because of such opinions, the role and responsibility of us scientists is even more significant. Finally, I am sure that you will again enjoy not only the technical presentation and valuable scientific discussion, but also the local hospitality, food, culture, and sightseeing of beautiful Dubrovnik. I wish all of us a successful conference. Thank you very much for coming and for your attention. The 20th SDEWES conference is opened. Thank you.
Thank you, Professor Guzovic. Now it's my great honor and pleasure to invite the chairman of SDEWES International Scientific Committee, Professor Henrik Lund. And as you can hear, the International Scientific Committee is the backbone of the SDEWES, ensuring the quality of our submissions, of special sessions, of special issues, and also of our keynote speeches and everything. So please welcome Professor Henrik Lund now on the stage.
Thank you very much. Ladies and gentlemen, distinguished guests and local organizers, dear colleagues, dear friends. It is indeed my privilege and also my pleasure to warm welcome you to the conference this year. It's number 20, so we have anniversary and jubilee conference. So let's celebrate that. I can see that many of you have been here before. I saw that during the reception yesterday, and also now there's a lot of familiar faces. And some of you have been here more than once before, several times before. To all of you, I would like to say a very, very warm welcome back to the conference. Then I can also see some of you are here for the first time. And indeed, those of you who are here for the first time, I always like to warm welcome you. And I hope you'll find it good to be here, and I hope you'll feel welcome. And I will call upon all of us who have been here before to make the newcomers very, very welcome in our society here. The conference started more than 20 years ago, and 20 conferences in the beginning. And as we have already heard here on the video and also on the speeches, this conference and this community is sort of a front runner, a very early mover in looking from a scientific point of view into this topic and those very big challenges we share. And we have been doing that. In my view, I think the most important thing about this conference is that we have been looking at how to solve the problems. Not only how to describe them, but how to solve them. And that's how we have been giving our scientific contribution, shared our knowledge, provided and developed the knowledge on how to solve those big problems such as climate change and also water supply and so on. So how to solve them is the key of what we do. But in this conference from the very beginning, and it's also put into the title of the conference, we do it in the approach in which we realize that this is not something narrow. This is not something where one technology can solve all of it. We have to take this a much broader approach in which technology have to collaborate with other technologies, and then we make the system that is part of our title. And it's not only looking at the energy or the environment or the water separately. It's when we look at it together and when we look at take this system approach, we will be able to provide the technically reliable, the doable, the affordable solutions to these greater problems. And our contribution as scientists is to tell how we can do it and how we can implement these solutions. And it's not only a matter of engineering, it's also governance. It's not only technology, it's also how to implement these technologies, how to involve communities, and all these broad aspects that we put together in this conference here. And when we do this, if we go back a few years, I would say we have an interesting and very important collaborations with politicians and authorities and governments around the world. And a couple of years ago, I would have said, now the governments and the politicians have done at least an important part of their job. They have provided us with ambitious goals for what we should do. Ambitious aims on to deal with these bigger global problems. And our job is then to provide the solutions. But I think all of us can see that, how should I put it, in certain corners of the political life, there are a few politicians that are in a situation in which they hesitate a little bit about being as ambitious as I think we need to be on the global level. So what should we do, we the scientists, in this current situation? Should we feel that we are not encouraged enough to do our part of the share, providing the solutions, and give up? No, I will say no. Now more than ever, there is a need for that we do what we do. Because our relation with the politicians and governments works both ways. By having ambitious political goals, they encourage us to identify the good solutions to that. But it also works the other way. If we can provide good solutions, technically reliable and also affordable solutions to the problems, if we can provide that knowledge, we will also give the courage back to the politicians and the citizens to be ambitious on the goals. And I think now more than ever there is a need for that. So now more than ever there is a need for us keep doing what we do best, provide the solutions, share the knowledge, because these are global problems. Share the knowledge among us and develop the knowledge and communicate the knowledge and give the hope and the courage for our collaborators on the political agenda to be brave and to keep up having ambitions to solve these problems. And with these words, I would like to welcome you all once again and also encourage you to keep sharing your knowledge, keep communicating, keep networking, keep doing what we do best. Welcome.
Thank you, Henrik, on these lovely messages and the brave start. So since its beginning, the conference was organized in Dubrovnik, and we got a lot of support from the local scientists from University of Dubrovnik. But we outgrew their facilities, and then we moved to this place, but we are now outgrowing even this place. So we need to see how we will continue in 2 years. But nevertheless, we are happy to have here a representative from the University of Dubrovnik, Professor Mato Brautovic, Vice Rector for Internationalization, Public Relations and the Student Standards of University of Dubrovnik, who will also be giving a welcome address. So please.
Distinguished guests, colleagues and friends, it's my great pleasure to welcome you on behalf of University of Dubrovnik, proud co-organizer of the Conference on Sustainable Development of Energy, Water and Environment Systems. Dubrovnik has always been a crossroad of culture, trades and ideas. Today, it becomes a crossroad for sustainability, where engineers, environmental scientists, economists and communicators meet to shape a more resilient and just future. This conference reminds us that sustainability is not a collection of isolated problems, but a system of systems integrating energy, water, transport, waste, building and industry. To succeed, we must think holistically, act collaboratively and communicate transparently. In my own field, the study of disinformation and conspiracies, I've seen how easily false narratives can distort public understanding, weaken trust, and stall progress. Whether it's climate denial or suspicion toward renewable technologies, these narratives can undermine even the best scientific and policy solutions. This is why the road to sustainability is not only technical, but also informational and cultural. We must build societies that are not only energy efficient, but also truth resilient. At the University of Dubrovnik, we see this intersection as central to our mission. As one of the youngest public universities in Croatia, we are building a model for education that connects science with society, combining technology, social sciences, and humanities to address complex global challenges. Through our research on media, communication, and public trust, we seek to strengthen the knowledge foundations to make sustainable transitions possible. Over the coming days, I encourage you to cross borders between disciplines, sectors, and ideas. Dubrovnik, with its centuries of openness and exchange, is a perfect setting for such a dialogue. On behalf of University of Dubrovnik, I wish you an inspiring conference filled with meaningful connections and new insights. Welcome to Dubrovnik, the city of openness, heritage, and innovation. Thank you.
Thank you, Professor Brautovic, on this welcome address. Maybe University of Dubrovnik is not big, but they have really remarkable results in maritime science, in communications, in economy and tourism. So you are welcome to collaborate with them in future initiatives. Now, I would like to give a little bit of statistics of this conference, just to see where we are standing now. So. Oops. As you heard, conference is organized by University of Zagreb and the Instituto Superior Técnico from Lisbon, Portugal, and under direct organization of International Center of Sustainable Development of Energy, Water, and Environment Systems. This year, we are proud to announce that we have 790 participants coming from 68 countries, 370 cities, and over 350 universities, institutions, and companies. We have representatives here from the 6 continents, and we are proud that we got to these really remarkable numbers. Maybe you can find here a flag of your country, but we look at it as a unite place because we have only one Earth and we need to work together to make it more sustainable. And maybe you heard some of the numbers, but you can see that we really started more than 20 years ago from Dubrovnik as a small conference supported by European funding, and since then we are growing and reaching the numbers that are really remarkable. So, as I mentioned, we have 68 countries here represented, but more than 795 participants registered both online and on-site. And what we are proud of, that we have maybe more than 1,200 received abstracts. And what is also not shown here, you know, there are combined numbers for some years because we have more conferences, but this year we also started the African conference in Saidia in Morocco, and the numbers for this year will be really bigger. So now you can see how the conference is growing, and when you have this idea and vision to share the knowledge, maybe we can expect these numbers for 20 years or even sooner in Africa, Latin America, and every other place where conference is present. So that's why we started the series of conferences on each of the continent. We try to gather the scientists and bring them this idea of sustainability. And maybe you are aware of this butterfly effect theory that says that, you know, flapping the wings gently of butterfly can cause the hurricane in Brazil, can cause hurricane in Texas. So all of these conferences are somehow of butterflies that caused really huge impact in current and society. So we have them from Southeast Europe to Latin America to Asia Pacific, now Africa, and you are welcome to add your butterflies here. And what we are proud of and why we are so strong in a quality conference, because we are, of course, followed by many partner journals which are published special issues from different topics, from different subjects, and we are really multidisciplinary. So we are proud to say that we have published more than 3,500 papers in distinguished journals, but also, as I said, we are not just providing the journals with the papers. The members of International Scientific Committee and members of SDEWES are becoming the editors of these journals, and we are proud that many of them are now here. So this is somehow a joint effort to grow together in more sustainable world. And since 2013, we decided to make the science of sustainability more open, and then SDEWES decided to form its own online journal, SDEWES, which is now, and from its beginning, it's the editor is Professor Neven Dujic, and publisher is SDEWES Center. We are indexed in many of the databases, but current impact factor is 2.2, and we are ready to open maybe publications for more journals, because more papers, because there is quite big interest for publishing. Then we also know that if we don't measure something, it's hard to make improvements. So we decide to start a new journal of sustainable development indicators, where we published already third issue in the first volume, and we are inviting all of you to submit your papers as the journal is becoming more and more popular. Similar, we have also decided to make another journal of sustainable development of natural resources management, which has two editors, Shi Wang and Professor Petr Sabe-Verbanov. It's also online open access journal, which published third issue, and it's also becoming more and more popular. And for the next year, we also decided to start a new journal, open access, so Journal of Sustainable Development of Smart Energy Networks, which will be edited by Professor Francesco Celius and from Italy, and we are proud to see the first paper published. Then, don't forget that we are not just present in this world, in this reality, we are also present in virtual world, and there is virtual conference going on, because it's impossible to follow all the presentations, all the sessions. You know, you have a limited physical time, so please join online conference, to watch all presentations that you didn't manage to see in this place, and try to ask questions to make all the response to the questions. Use this platform as a place where we can really exchange and get more ideas and become more and make more from our research. So the conference is ongoing, and also for the tracking the real-time conference, you join the website and you can see also the lectures and everything online. Until now, we have this really strict publishing rules, strict participation rules, so please follow them, as you know, your papers will be excluded if you are not here, if you don't present your posters, if you don't make presentations, and if you don't answer all the questions. So I hope that you enjoyed these statistics and that you are now more familiar with the current SDEWES conference. So thank you once again, and now I would like to invite Professor Neven Dujic to give as a SDEWES president, to give the introductory note on SDEWES' role in energy transition and climate change mitigation science. So, Neven, please, welcome.
Well, it's quite difficult to measure the influence of one conference, and I'm sure that each of your papers, of your presentations did move the world a little bit, but I will try to concentrate in this presentation on one topic where the influence is kind of measurable, and I think quite important. Since we started with SDEWES in 2002, this influence or this idea was slowly developing. Here you can see 4 invited talks at the first conference that was kind of showing the way where to go. Our first chair of International Scientific Committee, Professor Afgan, gave a talk on sustainability concepts. Our second chair of IC, Professor Lear, gave a talk about water demand and water desalination technologies, one important power-to-X technology or power-to-water technology. Professor Carvalho gave talk on new and renewable energy systems. Later on, she was working with Barroso on 2008 climate energy, the reform of EU, and now she is Minister of Energy and Environment. And finally, Professor Heinrich, one of the founders of the conference, gave a talk about pollution and modeling pollution. But that was also a time when I met Professor Henrik Lund, and we clicked because we were working on a similar problem. You have renewables, which are stochastic, wind and solar, available everywhere, but very stochastic, and then you have load, which is also changing during the day and during the season. I was working at that time on Porto Santo case, and I found out that you can't really solve this problem without integration of power system with other systems. And Henrik understood this. He was working on power to heat at that time, very important technology for Denmark. And then we understood we are pushing the same idea. And then, well, at the 5th conference, there was already talks about energy planning, about power to heat, about power to transport, power to water, power to hydrogen. All these bits have come together slowly. And at 9th conference, which was held on a cruiser in Mediterranean, already in the scope we have smart energy systems and integration of power, heat, transport, and water. It took time for the idea to grow to actual titles. Then if we look at IPCC assessment report 1 to 5, they generally recognize importance of renewables, but do not find ways for high variable renewable penetration system, and that results in hugely depending on CCS and nuclear technologies, which still did not happen. Maybe they will. Only Assessment Report 6 recognizes electrification of heating, transport, and industry as a way to go, but still does not fully solve this variable renewable penetration problem. What is the problem? You have wind and solar in your power system, and they're pushing out the baseload. So baseload doesn't play anymore because you have to shut it down twice a day. But you still have problem in the evening when there is no wind and solar. So how to solve that? Some places are already coming to the bottom of the duck curve, where you have most of electricity delivered during the day by solar, but you still don't have electricity for the evenings. How to solve the problem of renewable variability or intermittency, call it the way you like. So what we found during many of these conferences is that we need, of course, more grid interconnections. We need to flexibilize thermal power plants. We need wholesale markets to make it cheap. But the crucial step is that we need to develop demand response and integration of power, heating, cooling, transport, water and industrial systems in smart energy systems or power to X. We will also need dedicated electricity storage, but we should see it, at least in Europe, as a last resort. Maybe in solar belt, batteries will be the main solution, but here it's more complicated because sun is not shining all the year in the same way. If we look at this grid issue, if we have a small country like Netherlands, the pale blue line, wind is very variable, yes. But if you look on the continental level, the black line, wind is not so variable. And if we take last 7 years hourly data sets for wind, it's actually a baseload. It never stops blowing somewhere in Europe. But for that, we need more grid interconnection. And what to do with this excess of wind if we overbuild wind? In order to make that economical, we have to find solutions. Of course, cycling thermal power plants is a solution, transitional solution. We will eventually phase them out, but now it's very important. This is German coal power plants. You see them working now less than 2,000 hours a year. Also, nuclear is cycling heavily, which kills the economics of nuclear. We'll have a panel, but it does deliver very clean electricity. That's true. The price of electricity gets very low when we have lots of wind and solar in the grid. So what can we do with this cheap electricity? If electricity is cheaper than 25 euros per megawatt hour, it's actually cheaper than biomass on the heating value. And more hours, we're getting free electricity, negative prices. This is not really good because it hinders investment, but it's a huge opportunity for demand response. Let's convert this electricity into heat or into your car batteries. How to do it with the heat? We have beautiful Danish example. Skagen data is available online. And you can see when electricity price is low, then power to heat works. Electric boiler and heat pumps convert excess electricity into heat we're going to need later, so it's stored. And when electricity price is high, then cogeneration turns on and produces power and heat. Transport electrification has started. In some places like China now, more than 50% of cars are being sold are electrical. Europe is backward. It's only 20% at the moment. But if we look at developing countries, it's exploding. I mean, Nepal was 75% last year. Ethiopia was 60% last year. So we are going to be a bit not leading but following developing countries in the transition process. So what happens with the something that Henrik has given it the name, critical excess of electricity production, which is the electricity you cannot integrate in the system when you increase the penetration of, in this case, wind and solar together. So up to some point, up to 40% of wind and solar, there is no problem in integration. But then after that, you basically can't integrate anymore. But if you add power to heat, power to transport, power to hydrogen for industrial feedstocks, flexible as everything, adds more interconnectors, you are moving to the right. And this is particularly difficult system. It's a Bulgarian system, so it's mostly base load, and it was quite difficult to do the transition. But those are technologies that increase flexibility and allow a higher level of integration of variable renewables. So how do we do the whole thing? We overbuild wind and solar for factor 3, and we have most of the legacy electricity demand covered. This is the red line. It's missing still in few white spots, but we have hydro, we have geothermal, we have biomass, we have plenty of options which can be used, nuclear also. But what we do with the excess? If we just do not produce it, it's a lost money. But it's free. We can produce it and use it somehow. So if we do our heating, our transport with this excess electricity, we have improved the economics of the whole process. And we are still left with lots of electricity which we can convert to chemical feedstocks and fuels, which will be needed to decarbonize everything. So IPCC, in its assessment report 7, adds chapter 14 to the working group 3 on integration and interactions across sectors and systems. So we feel that our ideas are finally being recognized by the most important scientific body that covers this topic. We think that SDEWES conference series has helped this process with creating scientific evidence. I would like to thank for that process Natasha Markovska, who is national focal point at IPCC. I would like to thank Shir Kilkish, Vice Chair of IPCC Working Group 3, who worked very hard on bringing this idea to Assessment Report 7. I will be a coordinating lead author of, or one of coordinating lead authors of that chapter, so I will try my best to bring those ideas to the 7th report. Felipe Feijó, with whom we cooperate and who is also IC member of SDEWES conference. He is going to be in chapter on energy. And then we're going to have some very important speakers at this conference who have very good ideas how to make that happen. Lead authors in chapter 14, Christian Breyer and Marie Münster. But of course, many others helped that. It was all of you, and not only all of you, but all the previous participants who brought these ideas finally to influence the political process. So I would like to thank you for that, and I hope we are going to have many such results in other areas also. Thank you.
Thank you, Neven, for this very remarkable introductory note. I hope your messages will be shared among SDEWES participants. Now, I would like to invite Professor Shir Kilkish, and we will hear from her an an introductory note on sustainable development of energy, water, and environment systems to avoid increments of global warming. Professor Kilkish is a distinguished member of International Scientific Committee, and she will give this speech. Thank you.
It's my great pleasure to share the message on sustainable development of energy, water, and environment systems to avoid increments of global warming in this opening ceremony. Greenhouse gas emissions continue to rise, and this has important implications, as we have been hearing, on all of us, including also the remaining carbon budget to limit global warming. We are currently at 1.24 degrees Celsius of global warming, as the average over pre-industrial levels over the last decade. And the year 2024 was the first calendar year in which we exceeded 1.5 degrees Celsius on an annual basis. There are signs of progress on the side of technology developments. There has been sustained decreases in the unit cost of solar energy, wind energy, batteries, and large increases in their development. And the sixth assessment report of the IPCC did recognize the prominence of energy systems that can accommodate large shares of renewable energy, and there continues to be scientific evidence in this direction. Some of the scientific evidence has also been used to support the outcomes of the first global stocktake under the Paris Agreement, where it was emphasized the need to transition away from fossil fuels and energy systems in a just, orderly, and equitable manner, accelerating action in this critical decade, so as to achieve net zero by 2050 in keeping with the science. And also the option of tripling renewable energy capacity globally and doubling the global average annual rate of energy efficiency improvements by 2030. There are also multiple reasons to ban inefficient equipment, including for space heating, and new scientific evidence also looks on how a complete ban increases the likelihood of reaching carbon neutrality while reducing total system costs in over 75% of the scenarios as well. There's also progress in electrification, as we've been hearing. This is looking into the electrification trend in the residential sector over the last 20 years by country. And this is the electrification trend in total final energy usage in the last 20 years. And this is an initial basis for integrated approaches and towards the steps for smart energy systems as an initial progress. Studies on 100% renewable energy systems for countries beyond those for global and regional studies are also increasing, so this is another sign of progress. And this brings me to three key messages that have urgency of being shared in this presentation. These are covering messages on accelerating decarbonization, urban areas, and co-benefits for health and well-being. The first key message is integrating solutions can accelerate decarbonization and enable sustainable development. As a synthesis of recent themes coming strongly from the scientific committee, integrating solutions, as we have been hearing again, can provide cross-sectoral benefits. In this recent synthesis of themes, this has covered those on demand flexibility to energy system restructuring and providing multiple promising opportunities, including ways of achieving dual goals of providing technological opportunities and access to basic services. Let's look at the illustrative scientific contributions worldwide. There has been progress on energy scenarios with the H2RES model, optimization of energy systems towards net zero CO2 emissions by 2050, supporting national targets, and the opportunity of creating new direct energy jobs from renewable power generation technologies. There has also been emphasis on this integrated perspective and the need for policy synergies and rural electrification strategies, including in the least developed and electrified regions, where less than half of the population has electricity access, ways to improve rural health centers, and also looking at panel data, where investment and expenditures on renewable energy can increase social welfare, public health, and also lead to economic growth. There has also been, in connecting disciplines, studies on regional climate change projections, need for policy coherence involving energy access, job creation, energy affordability, air quality, health, renewable energy infrastructure, green hydrogen, looking into water quality together with environment systems, and energy flexibility of buildings, among many, many others. So continue on this international and global journey of scientific contributions, connecting disciplines, connecting systems. We can also say there has been views of and scientific evidence on water energy nexus, indicators for healthy and sustainable cities, pathways for hydrogen production, floating solar plants, and also evidence on community-scale renewable energy infrastructure. There has been many more, from connected options and ways for wastewater treatment, service water quality, and many, many others, including new per capita indicators, exergy per capita, hydrogen valley at the gigawatt scale, and many others, and these are available in that recent synthesis of illustrative scientific contributions worldwide. This brings me to the second key message on urban areas. Effective mitigation action in urban areas will have an impact on reducing emissions and additional increments of global warming. This is based on a new method that links urban scenarios with the transient climate response to cumulative CO2 emissions, covering 465 urban areas with urban emission scenarios and 135 urban areas with land use efficiency scenarios. In international assessments, the transient climate response to cumulative CO2 emissions is assessed and used to estimate future global warming. The best estimate is that every 1,000 gigatons CO2 emitted corresponds to about a 1.45 degrees Celsius increase in the global mean surface air temperature. Looking into different scenarios for urban areas and their cumulative urban emissions, this scenario, which is a green growth scenario with widespread electrification of end uses in the urban energy system, as well as energy and material efficiency, leads to cumulative emissions to 2050, and the best estimate of the transient climate response to cumulative CO2 emissions indicates an additional increment of global warming as 0.08 degrees Celsius. In a less ambitious scenario, the cumulative urban emissions increase and accumulate more, and this leads to a best estimate, based on the best estimate of transient climate response, to a 0.13 degrees Celsius increase of additional increments of global warming. All else equal, given human-induced global warming at 1.24 degrees Celsius, this result alone can result in a 1.34 degrees Celsius impact of these urban areas at a global scale. Another urban emissions scenario with green growth leading to 100% renewable energy in 2050 is limiting the cumulative urban emissions, and the best estimate of transient climate response also indicates about less than half of this additional increment at 0.06 degrees Celsius. And this also requires utilizing urban infrastructure and urban energy usage patterns as key assets for enabling sector coupling. Ordering urban areas from highest to lowest based on their contributions to increments of global warming across different scenarios indicates that urban areas with the highest contribution do have an important role in being part of the solution. but it is the collective mitigation efforts of various urban areas across the world. And action of all 465 urban areas are crucial for obtaining the climate action outcomes that are targeted. The way urban areas are planned, whether they're more compact or relatively more dispersed, also has potential consequences on the surrounding carbon sinks based on their local biomes and potential penalties on naturally sequestrating CO2 emissions, and this can lead to additional increments of global warming as well. Taking these together in the various combinations across scenarios, we also see that it's possible to avoid 87 gigatons CO2 equivalent of cumulative urban emissions between 2020 and 2025 when there are more ambitious actions. And an original parameter, the avoidance of increments of global warming, also indicates the possibilities, and the possibility of avoiding about 0.04 degrees Celsius of additional increments of global warming, with just 135 urban areas being on track for these pathways. So bringing together urban emissions and global warming consequences can strengthen the basis for action. Here we see figures on the net cumulative urban emissions in the x-axis and contribution to increments of additional global warming on the y-axis. When renewable energy is combined with better urban planning, we can also see that the net cumulative urban emissions is limited and contributions to increments of global warming are also limited. So this is really the best chance that urban areas can have in limiting additional increments of global warming. The third key message is focusing on co-benefits of mitigation that extend to health and well-being and ensuring a safer climate future. There are multiple lines of evidence, including the Lancet Countdown on Health and Climate Change, that underscore how climate change is the greatest global health threat. In addition, average global anthropogenic particulate matter 2.5 exposure remains over 4 times higher than the 5 microgram per cubic meter World Health Organization guideline threshold. Clearly, there are opportunities to avoid air pollution through smarter solutions, and recently, a multi-dimensional benchmarking tool, namely the SDEWES index, is interfaced with urban mitigation scenarios and health co-benefits. For the benchmarked urban areas in the SDEWES index and with urban emission scenarios, about 89% of emissions reductions can be attributed to urban areas that are benchmarked as challenging cities. And when we look in a less ambitious scenario, their annual urban emissions can hover around similar levels in 2030. In the 100% renewable energy green growth scenario, we also see that the solution space widens for all of the benchmarked urban areas. Here, comparing their potential contribution to increments of global warming across scenarios, it's possible to see that challenged cities can avoid about 69.4% of the additional increase of global warming attributed to these urban areas, followed by transitioning cities at about 14%, pioneering cities at about 10.2%, and solution-seeking cities at about 6.4%. So these urban areas do have possibilities to avoid additional increments of global warming as well. And is it possible to envision improvements in benchmarking with scenarios? The answer is yes. The lower data points, the data sets, indicates the existing benchmark performances of these cities. The middle data set, the yellow dots, indicates possible convergences in the near term, so when urban areas move up to the next possible performance. But the top data series indicates scenario-driven levels of performance for all the 97 urban areas when coupled with the more ambitious scenario. So urban areas can improve performances for sustainability through the more ambitious scenarios. And it is also possible to effectively limit current emissions and average concentrations of fine inhalable particles, particulate matter 2.5, as we see also here. Looking into different categories or quartiles of performances of these urban areas, it's also possible to consider evidence on integrated exposure response curves and analyze that it's possible to save 120,408 human lives, coming as the co-benefits of health due to better air quality. So this is also the human face, the human dimension of how climate mitigation and addressing sustainable development can go hand in hand for benefits for people and the planet. Progress that can be aligned with these urban mitigation pathways also include flexibilization of demand, for example. And through this, Rome can also have improvements of saving human lives, as well as urban mitigation actions across various urban areas. The multitude of topics in the scientific conference, from energy and climate policy, energy and environment, smart energy systems, sustainability, comparisons and measurements, urbanism, water and wastewater treatment and reuse, water desalination, and water energy nexus, among many others, show how it is possible to envision and enable these solutions. And it's the interconnections of topics within the scientific program that is sure to also provide the basis for new solutions. In addition, each contribution to the scientific literature is valuable for the 7 assessment cycle, for the assessment of the scientific literature, the evidence, as well as, in the meantime, the real implementation of solutions to address global warming worldwide. The panel did decide to have 3 contributions of the working groups on the physical science basis, impacts, adaptation, and vulnerability, and mitigation of climate change, in addition to technical guidelines, a special report on climate change in cities, methodology reports, and a synthesis report. It's also important to note that the special report on climate change in cities will have a review timeframe from 17th October to 12th December of this year, and it's very important to register on the website in order to provide your comments for this special report. So there are 3 key messages that I had the opportunity to share with you in this opening session, from integrating solutions, acceleration of decarbonization, effective mitigation actions in urban areas to avoid additional increments of global warming, and co-benefits. Thank you very much for your attention, and have an excellent conference.
Thank you, Shir, for this great introductory note and for offering all these messages, but also thank you for developing the SDEWES index and for your contribution to IPCC. We know that urban environment is crucial for sustainability because the villages are sustainable last 10,000 years. So maybe if you go to a village around Dubrovnik, you can also spot some butterflies, and I thought that I saw some butterflies on Shir's presentation. So I think there will be many hurricanes in sustainability world. But we are 800 here, you know, so if we will not follow the rules, we will have chaos, and then you know, the small deviation can cause really big influence, or something will be, you know, destroyed, or things like that. So to avoid this, I'm inviting Associate Professor Tomislav Pukšec, who is in charge of the local organizing committee here on site, and he is someone who knows the rules that we need to follow to have this smooth conference. So please welcome Professor Tomislav Pukšec, and he will explain us how to behave in this conference.
Thank you, Goran, for the introduction. I'm very happy to be here today on this 20th Jubilee edition. I will be quite quick and brief. I will give you some pointers on how we implement the conference, and I will be quite administrative and technical. As you could probably already noticed, the SDEWES conference is a hybrid one, which means we have an online part and we have an on-site part. But whether you're online or you are here with us in Dubrovnik, the crucial thing is that you present your research, because people are coming here to listen to you and to see your research. So the most important part is actually for you to present it. Whether you are on a parallel session, whether you are presenting your research on a poster session, or answering the questions in the virtual conference. Unfortunately, if your research is not presented, then your paper will be cancelled and your paper will not be included in the final proceedings. So be on time, be punctual. Before the beginning of the session, a local organizing committee member will be in each room, like 15 minutes before. So you can also come 15 minutes before the session. You can copy your presentation, test if everything is okay. Local organizing committee people will be in the rooms and they will assist you and they will help you in whatever you need. This also applies to chairs and co-chairs, a very important role here. You will get your instructions and papers and documentations also from the local organizing committee members, so also be like 15 minutes before the session starts so we can prepare everything and have like a very smooth sailing regarding the sessions. As you, I don't know, some of you probably are here for the first time, but the conference will be held on the 2 levels. On this, let's say, lower level, we will have rooms A, B, C, and D. Currently, rooms A, B, and C are connected in this big hall. On the 2nd level, you will have your rooms E, F, G, H, I, and J, and the registration desk where you probably all already been and registered. Here in front of room A, we will have all of our coffee breaks. The first one will be after this session. And we will have our lunch breaks in the restaurant of the La Croma Hotel. So it's just in front of the room D. It's basically on this level. Each of you got your name tag and you got your tickets for lunch and for the social trip on Wednesday. So you have your lunch coupons for each day, which you will need when you're entering the restaurant to go for lunch. And you will have your social ticket coupon for the Wednesday trip. Please always have your name tag with you and your coupons with you when you're at the conference. On Wednesday, you will definitely need this ticket, the social ticket part, when you are going to the trip with us. We have a special section on the webpage which is very detailed on our social program, so you can always check all the information, but I suppose you already decided which trip on Wednesday you are planning. Of course, we will give you all of the detailed information for the trips on Wednesday morning. We will have all the information all over the sessions and the hotel, but you can always check everything online. One also technical note, since we are like quite a big conference, the lunch will be a little bit different this year in a way that the dessert will actually be served right in front here and not right in front where the coffee break will be held and not in the restaurant. So basically after you had lunch, you can have the dessert here where the coffee break will be held. I mean, this year we will have numerous panels, invited lectures, excellent papers in parallel sessions, in poster sessions. Poster session will be held right behind me, so right behind room A. You will have the poster session, and the poster sessions will be held always during coffee breaks. So it's an excellent opportunity to have coffee and stroll down the poster session and engage with the authors, ask questions, and so on. To conclude, I will just with one technical note that after we finish with the opening ceremony and after we finish with the awards ceremony that you are all probably waiting for very eagerly, we will have a group photo before the coffee break. For now, the weather looks quite good. So I think the group photo will be held right outside. There's like a big patio and then stairs. So our local organizing people will try to guide you there, but it's basically very simple. You just go right outside and turn right. And we will have a very quick group photo, and then you can come back for the coffee break. Goran will try to explain and just remind you after we finish the award ceremony. So to conclude, I'm very happy that you all came to Dubrovnik. I hope you will have a great time here. I hope you will have excellent discussions, meet new people, meet new friends, engage and start up some new cooperations, maybe set up new projects or project proposals. And all in all, I really hope you will have an excellent conference here with us. So thank you very much.
Thank you, Tomislav, and all staff behind the organization of conference. So we are all count on the chairs and co-chairs of parallel sessions to follow the instructions and make the conference successful according to the plan. Also, as you heard, the dessert will be served outside, but when you come to the lunch, maybe you don't need to wait for the main meal. You can start with the soup, with appetizer, etc. So there is different islands, and try to, be supportive, as the lunch break is 1 hour only. So we will manage this, but it's also up to you. And now, finally, we are coming to the end of this opening session, maybe to the most important part, where we have Professor Natasha Markovska, SDEWES Vice President, who will lead the much anticipated award session. So let's see who is who won the best paper, but also the other SDEWES awards. Please, Natasha.
Good morning, dear colleagues, distinguished guests, and members of the SDEWES community. It is my great pleasure to welcome you to the awards ceremony of the 2025 SDEWES conference. This session is dedicated to celebrating the achievements of our colleagues who have made outstanding contributions to advancing sustainable development of energy, water, and environment systems. Today, we will recognize and honor the authors of the most cited SDEWES paper, the authors of the most cited JSDEWES paper, the authors of 3 best papers, the most loyal SDEWES conference participants, and the honorary awardee for the year 2025. We have an inspiring lineup of recognitions today that reflect the excellence and diversity of our community. So let us begin with the awards for most cited papers, those whose impact has resonated strongly within our field. This award is presented to the authors of the most cited paper published in one of the SDEWES special issues of our associated journals. The most cited paper is determined by the number of citations a paper receives during the 2 calendar years after publication, adjusted by the journal impact factor. The recipients of this award will receive certificates from SDEWES, along with a book authored by a member of SDEWES International Scientific Committee. This year, we are acknowledging the winner of the most cited paper from SDEWES 2020 conferences. Second, Latin American SDEWES in Buenos Aires. First, Asia-Pacific SDEWES in Gold Coast. The fourth, Southeast European SDEWES in Sarajevo. And the 14th SDEWES in Cologne. The award goes to Ramchanda Bahandri and Ronak Rakesh Shah for their paper titled Hydrogen as Energy Carrier, Techno-Economic Assessment of Decentralized Hydrogen Production in Germany, published in Renewable Energy. Their work provides a comprehensive techno-economic evaluation of decentralized hydrogen production systems in Germany and contributes valuable insights to the global transition toward renewable energy. As part of recognition, the authors will receive the book award Solar Energy Engineering Processes and Systems by Professor Soteris Caligiro. Now, I would like to invite the recipients or somebody on their behalf to the stage to receive the award and address the audience.
I'm not Ramchanda, I'm brilliant.
Next one, the most cited SDEWES paper. This award recognizes the authors of the most cited SDEWES paper published in the Journal of Sustainable Development of Energy, Water and Environment Systems. The selection process considers the number of citations received by each SDEWES paper over the 2 calendar years following the year of publication. The paper with the most cited SDEWES paper will receive certificates from SDEWES, a book authored by a member of the SDEWES International Scientific Committee, and also an additional token of appreciation, 2 SDEWES coins. Each SDEWES coin carries the value of 1 SDEWES publishing fee. Thus, the awarded authors will receive 2 fee waivers for publishing their future work in SDEWES. This time, we are honoring the winning paper from SDEWES volume number 10. The award goes to Nicholas Sean, Elena Timotieva, and Boris Hens for their paper titled Sustainable Development Goal Indicators as the foundation for holistic impact assessment of access to energy projects, which was published in volume 2, the year 2022. Their paper presents a thoughtful and comprehensive framework for evaluating access to energy initiatives through the lens of sustainable development goals. The recipients also receive the book award, Assessing and Measuring Environmental Impact and Sustainability, edited by Professor Jerzy Klemes. Congratulations once again to the authors for this meaningful and impactful contribution. The Best Paper Awards honor the highest quality research paper presented at SDEWES 2025 conference. This time we received 50 nominations by the editors or reviewers covering nearly all archival papers. Each nominated paper was carefully reviewed and evaluated based on its scientific quality, originality, methodological rigor, and relevance to SDEWES topics. After a detailed review and scoring process, the awards committee selected 3 outstanding papers for recognition as the third, second, and first best papers. Before presenting the Best Paper Awards, let me introduce the members of the SDEWES 2025 Awards Committee. It has been my honor to chair this committee, which includes Professors Ofelia Arujo, Shir Kirkish, Brian Vett-Matenson, Antonio Piacentino, Ingo Stadler, and Alexander Zidanšek. I sincerely thank each of them for their dedication and valuable contributions throughout the selection process. Our task was both challenging and rewarding, given the exceptional quality of all submissions. Now, without further delay, let us proceed to unveil and celebrate the outstanding authors of the 3 winning papers. We begin with the third Best Paper Award. The third Best Paper Award goes to the mosquito algorithm as a new tool for demand response and energy storage management for time pricing optimization by Daisy Diaz-Bello from Spain, together with her co-authors. Their research introduces an innovative bio-inspired optimization approach to enhance energy management efficiency. The recipients also received the book Renewable Energy Systems, a smart energy systems approach to the choice and modeling of 100% renewable solutions by Professor Henrik Lund. Now I invite the recipients to the stage to receive the award and address the audience.
So thank you very much for this honor. I really appreciate the consideration you have given to our work. We are open to discuss it with all of you, of course, and we are really happy to be here. So in a sense, we are more integrated now than ever. So thank you very much.
The second Best Paper Award is presented to cryogenic carbon capture using phase change thermal energy storage materials by Lizhong Zhang from China and his co-authors. This paper presents a compelling and technically advanced approach to improving carbon capture performance and energy efficiency. A truly innovative contribution deserving recognition. The authors received the book Sustainability in the Process Industry, Integration and Optimization, edited by Professors Klemesh and Varbanov. I now invite the recipients to the stage to receive the award.
Thank you, everybody. Good morning. Very good to be here to receive this award. SDEWES has been a little bit special to me because before I even do my PhD, I found a thumb drive left over in the drawer of my office when I first reported to Nanyang Technology University of Singapore. It's basically a thumb drive of a SDEWES conference. And after 8 years, next year, we will be chairing a special session in Shenzhen of the Asia-Pacific SDEWES conference. So what a journey. And I want to thank Prof. Nevin for making this happen every year. It's a super important gathering for all of us, and Prof. Natasha and your committee members for recognizing our work. I also want to thank my co-authors for this brilliant work, Prof. Paul Wen Liu for coming up with the brilliant idea together with me, Prof. Alessandro Romagnoli, who led a team to dedicate to cold thermal energy storage for so many years, although not on the author list, but Dr. Jiaying Xue, who developed the material that we've been used for capturing CO2 finally. It is a thermal energy storage material. And most important, Dr. Core Juno, who is also here today, and not only for contributing to this work, but also being a father of a 2-year-old baby, Olivia. I wish her a happy and wealthy life in the future. Maybe we can applaud Dr. Core over there as well. And maybe the last but not least, I wish all of the Chinese researchers or Chinese descendant researchers in this conference today a very good, happy Mid-Autumn Festival. 中秋节快乐. Thanks.
And now, the first Best Paper Award. The first Best Paper Award goes to Variable Renewable Energy and Distributed Generation, Economic Impacts on New Zealand Electricity Markets by Jake O'Leary from New Zealand and his co-authors. Their paper provides an insightful analysis of the economic and policy implications of distributed renewable generation integration. The recipients also receive the book Solar Energy Engineering, Processes and Systems by Professor Soteris Kalogiral. I now invite the recipients to the stage to receive the award.
Thank you very much for this fantastic honor. This is my first international conference, so it comes as a little bit of a surprise to me, but yeah, a pleasure to be here all the way from us in New Zealand. So thank you very much to all of those who've paved the way. I'm a new researcher in a lot of these fields, and I'm building on the backs of giants, so to speak, and yeah, hoping to progress forward and further into the future. So thank you very much, and look forward to meeting some of you in the conference.
Before we move on the next award category, I would like to highlight that this year's results reflect a commendable geographical diversity and gender balance among award recipients. It is truly encouraging to see such representation: 3 different countries, New Zealand, China, and Spain, spanning 3 continents, and a balanced participation of both genders among the lead authors. Notably, the lead author of the third best paper is a female researcher. So now we're going to move to Loyalty Award. Few words about the award. Beyond excellence in research, we also honor those who have stood with the SDEWES family year after year. Now, let us move to this category. The award is dedicated to recognizing the most loyal participant of SDEWES conferences, honoring many years of active engagement and contribution to our community. The Loyalty Award goes to Professor Reinhard Haas from the Technical University of Vienna, who has participated in an impressive 13 SDEWES conferences since the year 2011. His continued support, intellectual contribution, and enthusiasm are deeply appreciated. Professor Haas also receives the book Renewable Energy Systems, a smart energy systems approach to the choice and modeling of 100% renewables and renewable solutions by Professor Henrik Lund. I now invite Professor Haas to the stage to receive the award.
Thank you very much for this great award. I would just like to mention that I really appreciate this format of SDEWES. I think this format is really unique worldwide. First, in the variety you have, for example, on the topics. Second, you have a broad and broader growing variety in the venues where you have the SDEWES conferences. And third, I think it is very important to address different fields of sustainability in such a conference. So congratulations especially to the founders of SDEWES, especially also to Neven Dujic and all the others supporting this event. And I'm proud really to be here today. Thank you. Hvala lijepo.
Finally, we come to the honorary award, one of the most prestigious recognitions of the SDEWES community. This award is presented to individuals whose lifelong contributions have significantly shaped and strengthened our field. Over the years, the SDEWES Honorary Award has been presented to distinguished colleagues whose leadership and scholarship have left a lasting mark on our community. Previous recipients include Professors Naim Afgan, Jordan Popjordanov, Simeon Oka, Ivo Schlaus, Kemal Hanjelic, Maria da Graça Carvalho, Vyacheslav Kafarov, Jiří Klemeš, Tarik Kopusovic, Nikola Ružinsky, and Krzysztof Urbanec. Their legacies continue to inspire our growing community. And this year, it is my great pleasure to announce that the 2025 Honorary Award goes to Professor Nikola Rajakovic in recognition of his many years of service as International Scientific Committee member, his role as organizer of the third Southeastern European SDEWES conference, his involvement in special sessions, and his valuable editorial contributions. His affiliations from Serbia reflects the very roots of SDEWES' mission to advance scientific excellence in Southeast Europe. Now, I invite Professor Rajakovic to the stage to receive the award and address the audience.
So I'm really honored to receive this award. It's a pleasure to be here and to say that my small but continuous contribution to the SDEWES community has been recognized. Thank you very much to the award committee. Thank you for recognizing my work. We heard a lot today. Number of interesting points. Topic is quite hot. So I would like just to add maybe two aspects important from my point of view for SDEWES conferences and for the SDEWES community. The first aspect is communication, collaboration, and synergy among all of us. I think it's SDEWES. Every single conference proves that is a realistic goal, to work together, to find the solutions for the very tough problems we face at the moment from the point of view of climate changes. And the second aspect, I think we have to work faster. That is my main objective during the last several months, because I think we are a little bit late from the scientific and practical point of view, and we have to be better organized and to offer to the politicians, to the people which make this, to the decision makers, we have to offer very clear and precise solutions for the future world. Thank you once again. Again, great pleasure being with you, and I wish you all the success through next 5 days. Good.
On behalf of the awards committee, I extend my heartfelt congratulations to all of the awardees. Your achievements, dedication, and creativity continue to raise the standards of excellence in our SDEWES community. I would also like to thank all participants, authors, reviewers, and organizers for contributing to yet another successful SDEWES conference. Let us continue to collaborate, innovate, and inspire one another in the years to come. Congratulations once again, and let me take a moment to celebrate their success together. Please join me in a round of applause. And now I invite all awardees and all present members of the award committee to come forward for a joint photo to mark this very special moment. With this, the award session is closed.
The session. Please take a seat and okay. Thank you. Good morning, even from my behalf, and welcome to this keynote plenary session. It is my great pleasure to chair it. And it is in particular my great honor and privilege to introduce our today's plenary invited speaker, a very distinguished scientist, Professor Ruzu Wang, who is going to address, perfectly in line with the jubilee significance of this SDEWES conference, our historical topics as SDEWES conferences with regard to energy, water, and environment systems, providing us an interdisciplinary exploration and focusing on the cross-relation among these different domains. Well, Professor Wang is a worldwide leading researcher in energy efficiency and energy conversion and chair professor at Shanghai Jiao Tong University, where he is also director of the Institute of Refrigeration and Cryogenics. He is certainly known even to the youngest of you also for being the current energy-in-chief of Energy, the international journal, and he has received a lot of recognition for his research activities, mainly established in the fields of heat pumps, green building energy systems, and energy water-air nexus. Author of more than 700 papers with over 40,000 citations, he has indeed received 3 national research awards and prestigious academic international awards, such as the Gustav Lorentzen Medal from the International Institute of Refrigeration and the Rittinger International Heat Pump Award from the International Energy Agency. In 2023, he was also awarded as a Global Energy Prize laureate in the New Ways of Energy application category. Then, Professor Wang, we can't any longer wait to benefit from your lecture, titled Energy, Water, Air, Food, a Nexus Approach. So I would like to invite you to reach the stage, and the floor is yours. Thanks.
So good morning, ladies and gentlemen. It's really my great honor, and I was invited by Never and also Henrik to have this lecture. And because it's my third time to come to this conference, and it's a really honor for the 10th Jubilee annual meeting for this conference. So my topic is actually for energy, water, air, and food, a nexus approach. So it's a big picture if we talk about energy, water, air, and food, because for the United Nations, for the sustainable goals, it's related all to this. So, but for this research, it's a multidisciplinary research. In this case, 7 years ago, I established a small team, so-called innovative team on energy, water, and air. So this, I would like to say, in the last 7 years, what we have done, and to share our experiences. So why ITAWA, this team, was founded? So I started for this. Actually, this was the origin from publication, from science, from MIT, Professor Emily Wang, and also Professor Omayage. And maybe Omayage, maybe next 2 days, we will see whether he will succeed with the Nobel Prize for chemistry. Yeah? He's a good candidate because he's the father for morph materials and cough materials, because they invented the technology in very dry regions with relative humidity 20 to 25%, with morph 801 could capture water and then generated with solar to release to get water for drinking. So this actually created a very, very strong point that a lot of people, they take attentions how to do some research work for atmospheric water harvesters. So actually, for this kind of researches, for our research group, we had a long term for this kind of studies. And also, just start from 2002, we started this kind of research. At that time, we have publication in China. But then later, the student, so one student, Jiaying Wang, she is here, now she is an associate professor. So when she was a PhD student, she did the research work. And when the science paper was published at that time, in our laboratory, we have built the machine to get atmospheric water harvesting every day for 50 liters. So then, this makes our group to think, why 1 gram of water from morph materials, from very dry area that you get the publication in science, but we take 50 liters of water, we can only publish in applied thermal engineering or energy. So in this case, we made some considerations. And also, some years ago, we had some research work for the air conditioning, whether it's possible to get latent heat and sensible heat separated. And we created some technology to use desiccant materials coated on the heat exchangers, and we're using desiccant absorber moisture for dehumidification. In this case, for air conditioning, electric driven is used for cooling, but dehumidification was done by the desiccant materials. But for the desiccant material, you need to consider for the regeneration, we're just using the condensing heat for regeneration. So in this case, we could get a normal COP value for air conditioning to get 100% increased. So this has a great impact. But at that time, it's in the beginning that we try to seek the possibility to publish in high-impact journals. But at that time, had no experience. We submitted to Nature, and then transferred to Nature Communication, and then at last, finally, scientific reports. So my student told me, Professor Wang, scientific reports is also a part of Nature. So in this case, at last, I finally accepted we submitted, and also go through the peer review process, and at last we pay $3,000 for the payment. This is an open access journal. So this is actually a very good publication, but unfortunately we had very good results, but finally is not in high-ranking journals. But we had another attempt. So because due to this experience, so when cell-based journal, so-called JOR, was launched, and the second year, in this case, because the impact of atmospheric water harvesting in the world, then I contacted with the editor-in-chief of this journal, Phillips Ellis, and whether they are interested if we contribute a review article. So then my proposal was accepted by them, and then we prepared, so the 3 students work with me, we prepared for the review paper for JOR. So it was published in August 2018. So this was the first time for me that I think now we have already contact with a high-impact journal. But at that time, the impact factor not yet ready. But I think this is a good journal. So in this case, this helps us have this kind of research and also encouraged our students. So this is why that I wanted to found a so-called innovative team on energy, water, and air. So because our team is working with solar energy, working with air conditioning and heat pumps, and also desalination. So energy, water, air are main criteria of my research group. So in this case, we consider also supported by the National Natural Science Foundation of China. So we encourage the researchers from 0 to 1. And actually, for my research group, we have long-term publications for 1 to 100. That's a LEA engineering program. For my group, even we published nearly about 100 papers in energy, actually. So in this case, we consider whether we could do something from 0 to 1. That means this is originated from this research that we could publish high-impact journals. So at that time, I set the goal every year, the small group, we need to publish 3 to 5 high-impact journals, minima Nature Communications, and even more higher journals. So then we start the exploration, try to exploring ground-breaking basic research from 0 to 1. So the first success is for the research and published in 2019, also in JOR. It's our completion, the first research papers. Really, we did for 2 years. And the student, actually, at that time, a lot of considerations for solid refrigeration, solid state refrigeration. Actually, we're using thermoelectric semiconductor cooling. But also we are doing with the humidity. In this case, we coated the heat exchangers of the thermoelectric cooler, the both side, coated with MOF materials. And for the colder side, when we take it from low humidity, we could uptake moisture. And then moisture absorbed by the cold side, and then we switch into the hot side, just to switch direction of the AC, from electrical current flow. So in this case, you get the regeneration. So in this case, we just make this switch. We could easily take moisture, very low humidity, to a high humidity. So in this case, it's a kind of concept, humidity pump. So in this case, we combine the concept of solid refrigeration with humidity pump, and then at last it was published in JOR. So meanwhile, we had a second research paper, because at that time, for SARE, they launched another new journal called iScience. So we published another one for the solar-generated dehumidification. Actually, we took humidity from inside the door and take it into the outer side in the absorption panel. But the outer side, we have a selective coating to absorb solar energy and to release humidity. So in this case, it's a kind of concept of humidity pump. So based upon these researches, because if we succeeded, one student succeeded, other students will be very, very active, try to do their best. So in this case, I think we had a lot of engineering work. 1 to 100, normally there's a big system, but for 0 to 1, usually a small system. It's a concept, mostly related research with materials. So in this case, we created some rooms and also have a plate, and I put some target journals for the students. I ask that whether in the next several years, we just fill the blank to see what kind of publication we could contribute. And meanwhile, so there is also a very important conference. This is ASME International Conference of Micro Nanoscale Heat and Mass Transfer Conference. So the conference organizer invited me several times to deliver a keynote lecture for the conference. But originally, I never participated in such kind of conference because I think I'm not doing nano scale. I'm doing the scale up system. But after half a year, they contacted me again. They said, Professor Wang, you are doing adsorption refrigeration. You are using adsorbents. Adsorbents should be nanoscale. Why not? If we need somebody to say this, who will be most suitable? So finally, I think if you want me to say something of adsorption refrigeration, it's my research area. So in this case, I agreed, but for the conference, the topical I set it as an adsorbent relative to energy, water, and air. So the reason is that at that time, already we started the research work, at least 2 papers published in JOR, and other papers on the way under review. So in this case, I think it's good that the opportunity to communicate our research results with the international experts. And also this is for the desalination. So Professor Xu Zheng, at that time, the young faculty member, so he is also today here. So we developed a lot of research work with solid desalination. And also, finally, so we started from 2018, and finally, 2019, after 1 year, so everything finished, and we sent our facility to MIT. So because we have some collaboration to be testified in MIT. So this helps us that this research is more well respected because it's from MIT. So in this case, we collaborate with MIT, and also finally we got good publications in energy and environmental science. So meanwhile, we tried some researches for the breakthrough in advanced materials. So we did some research work for the PCM materials for thermal storage. So in this case, thermal conductivity is very critical. So there are a lot of researches for enhancement of thermal conductivity of PCM materials, such as nanofibers and so on. But for us, if we consider we need to build the scale-up systems, we must use engineering materials. And in this case, we tried expanded graphite, because expanded graphite, you could try to make it into like a plate and also scale up. And in this case, we could integrate this with PCM materials. And then also into a fixed form. In this case, we could increase the thermal conductivity for nearly about 70 times to compare with PCM. And finally, so this paper was published in Advanced Materials. But in this case, we collaborate. Also, the second last author, he is a very famous professor in Shanghai Jiaotong from a School of Materials. So in this case, he instructed a lot for us how to get a publication in material science. So this actually is a very good story. So in this case, we succeeded with JOR and with advanced materials. So this makes that the whole group, especially the young students, inspired. And the inspiration is very, very important. And when this happened, I see before 8 o'clock, when I arrived at my laboratory, there are students doing experiment. So this, I think, just make the whole research group very, very inspired and active. And then, in the spring of 2020, we had publications, another publication in JOR, and energy storage materials, February, energy environment science, and Anger chemie, and then March, energy storage materials, and ACS material later. So this is actually several papers of the student. And at that time, Shanghai Jiaotong University, actually the homepage, at that time, there are 5 papers, but 4 papers from our research group. And due to the COVID-19, so scientists nearly isolated, but at that time in China, we are free to move. But in the United States, actually, it's not possible for the scientists to come to the laboratory. But MIT, in this case, they organized international curricula on thermal innovations. This is suggested by Professor Gang Chen and also Professor Emily Wang at MIT, at the department head of mechanical engineering. And then Professor Emily Wang called me, and she's told me that we need to have this specific topic for water harvesting. So Professor Wang, who should be the lead candidate to organize this kind of workshop? So in this case, we suggested this group, and then we broadcast online for this kind of just a seminar. So this is actually the seminar, and the MIT make the promotion for all speakers. So this is very important because I was promoted by MIT, and also to be honored, very honorable to be invited by MIT to do this online. And this is actually the topic for extracting water from air, energy, water, air nexus. This is the time, my talk in July. So then, after several years, this is to the end of 2024, all this is publication, because originally we cannot imagine, because my target is every year 3 to 5 high-impact journals. Now we had publications in Nature Living Materials, Nature Water, and JOR, and Energy Environment Science, and Nature Communication, Advanced Materials, so on. So this makes the whole group. We have 4 faculty members and nearly about 20 students involved. So in this case, this helped a lot of new achievement and also inspired the whole research group. Now I say something, what we have done for 0 to 1 and 1 to 100. So our research focus for Itawa team, normally we have atmospheric water harvesting and thermal management for electronics and also dehumidification, humidity control, and energy storage, and also greenhouse for the plants, and also heat pump and energy storage, and then desalinations. So I just say some examples. The first is for atmospheric water harvesting. So this just shows, for the start point, we had publications in applied thermal engineering, and then again applied thermal engineering, and then energy. So we have several steps that start from the materials, ACF, graphite, and silicon gel. And in 2015, we got 0.3 kilogram water for 1 day with solar. And then in 2016, 14.5 kilogram water per day, and 2017, that's 50 liters. So because we got the project to develop a unit more than 30 liters water per day driven by solar energy. So this is the steps that what we have done. But for the final steps, I asked Jane, and we tried to go through the high impact journals. And in this case, we had submission to Science, Nature Communication, Journal. So mostly sent to review, but finally rejected. The reason is that the concept of the final form is similar like that before, because there are no changes, but performance much better. So in this case, at the last we published in Energy because the student needed to finish her PhD. But also, we did some research work with morph materials. So based upon the experience from MIT and UC Berkeley, and all research group, we are experienced. Because even for the morph materials, for absorbed water, it has a limited adsorption because it's a physical adsorption. We did also a lot with chemical adsorption. So in this case, we're using lithium chloride, and I try to get lithium chloride water impregnated into the micropores of the morph materials. So in this case, what we could see that this work for the adsorption with the moisture. So it's to compare with the regular ones, it's much improved. And also based upon this, we did the work, get a passive solar-driven atmospheric water harvesting. And finally, this paper was published in Anglo Chemie International Edition. And also, we tried to use solar energy using solar collector directly, and we integrate solar panels, and in the backside with a condenser. So during the night, we open the adsorption, and during the day, seal it and close it. And then solar radiation heated, and we could get liquid water that's condensed from the condenser. So in this case, 1 square meter, you could nearly get about 800 grams of water. So, and also the size is very, very compact. And then later, we think it could be possible that to use solar energy, continuously operation, if the daily. In this case, we need the adsorbent with a high-speed adsorption and high-speed regeneration. So in this case, we're using lithium chloride onto this nano-composite adsorbent, and we're using specific technique to improve heat and mass transfer. So in this case, at last, we established solar-driven rapid cycling AWH devices. So in this case, for 1 day, we could operate maybe 8 cycles. So in this case, 1 day we could make good uses of solar energy efficiently. So this just shows 1 square meter per day, we could get about 2.3 liters of water. Also, we tested another results to the same arid region in the desert area. And what we have done is that that area usually adsorption is very, very slowly, but we put adsorption materials in the night to adsorb moisture from the air during the day for the regeneration. But we need a very short time for regeneration. So in this case, I suggest we get, maybe this is 8 units of this kind of adsorbent. So then during the day, each unit, so then we could generate 8 times. So in this case, we could get the more high yield of AWH. So this paper was published in Nature Communication. Later, I had visits and from company they wanted to make it a commercialization. And later I will show you. So now we have a commercialization for atmospheric water harvesting. Also, the student, they learned how to do this kind of, just like in the theater, just somebody, they have a specific technology. That means using morph materials, whether it's possible that we make a rotation that every day, 3 plates, and make it continuously adsorption, desorption. So this got actually 1 day per kilogram of to get about 2.11 liters of water. And also we are working with interconnected polar stir for high efficiency continuous. That's a solar atmospheric water harvesting. Actually, this is a specific machine, and we take hydrogen, just rotate. So when it's outside, so you get that's adsorption, but when it comes to the concentrated solar, you get a regeneration, and in this case, get a moisture water condensed. So in this case, what we have done to get 1 day per square meter, nearly about 15 liters of water. So this is a very, very big increase to make that this kind of technology could be market available or market interested. The second topic for the research is for electronic thermal control. And some years ago, that before I do not consider that we are doing this, but with this kind of morph materials, I considered that for the mobile phone, for example, so we using the near standard mobile phone for the testing, and when the electronic working load is lower, if it's coated with morph material, it could absorb moisture. But when the load goes higher, the temperature goes higher, so the absorbed moisture will be released. In this case, you will reduce the temperature. So this is a kind of, we call it sweet cooling, because it's similar like a human body for the sweet cooling. But for these cases, we demonstrate for the mobile phone, normally the maximum temperature could drop nearly about 8.6 degrees centigrade. So this verifies that it's very efficient, because for the materials of adsorbent with moisture, normally this is desorption heat is nearly about 2,000 joule per gram. To compare with PCM, nearly about 7 to 10 times increase. So in this case, you're just using about 1 gram, you will get such kind of electronics, the temperature, the well controlled. And also, students also practice with the battery thermal management, and just coated with morph material, and try to do the test and find that in this case we could also control the battery temperature below 45 degrees and realize self-preheating with increase in the battery capacity of 9.2%. So in the summer, cooling down, but in the winter, heating up by adsorption. So cooling down by desorption. So we tested such kind of batteries, and it's demonstrated here to be, try to keep it always working in a safe region of the temperature. And based upon this, we also tried, because my research group had a very good collaboration with Huawei for 5G station actually. And in this case, originally we had optimized our 5G stations, and because from 4G to 5G, Huawei wanted to keep the size unchanged. In this case, asked us to make an optimization of heat exchanger. So it was successful. So nearly about 10 million units. Over the 10 million units, they used our structure. So we had a very good partnership with Huawei. So in this case, I am considering whether for 6G, how to use. In this case, I suggested to using this kind of sweetening cooling coated on the heat exchangers. What we have found for the 5G station we tested, we could get nearly about 20 degrees maximum temperature reduction with nearly cooling power, 600 watt per square meter. So in this case, this could be a very important issue. So finally, we had a passive thermal management of electronic devices. This is just a review article, so publishing device. We try to introduce how this could function. And so we try to consider its use for mobile phones, 5G stations, and any kind of batteries and so on, for the, even for the battery of charging and so on. And very recently, so my students think we could also do the PV cooling, because of photovoltaics in China, so we have a huge photovoltaic power station, but especially in the desert area, after use for a long time, there are a lot of dusts, but usually no water there. So they have a requirement to use water for the cleaning. So in this case, we tried the possibility to use a sweet cooling to cool down the PV photovoltaics. In this case, you could increase the energy efficiency to generate electricity. But meanwhile, we could produce water. So this is a concept for this research. So it's in the example to use future energy. So this is published in Joule. And now we are doing the real one, and also cooling down of photovoltaics, but also meanwhile produce water. So the third topic is dehumidification and humidity control. So we start from this Joule. At that time, he was a student doing PhD work for 5G mobile phone cooling for Huawei. But this is not related to his PhD work, but he interested to this. And very fortunately, he got the first research publication in Joule. And then another student, actually his wife, they are classmates and working together. She becomes his wife. And she's doing for the nano energy. We published one paper for exergy efficient boundary and design guidelines for atmospheric water harvesting. And so in this case, we clarified to gate AWH. So in the climate regions, what's the boundary conditions? And also, 23, this is a postdoctor from that's Primož Petrović. I think some of you may know his father, Petrović. That's from Slovenia Energy Association chairman, actually. So he became my postdoctor. And so when he was a postdoctor with me, he contributed one paper in science, one paper in Joule, and also one paper in energy environment science. So this just the idea, so-called sustainable cooling with water generation. But the editor would like the idea if it's possible to have these dual uses in the dry areas. So we just proposed a good idea how to reach dry area for cooling and also atmospheric water harvesting. And also another student we did using a thermoelectric cooling coated with morph materials. Originally, we did for the humidity pump now, but this is also used for the atmospheric water harvesting to try to make it a very compact unit to get water harvesting. So 1 kilogram of material to get about 2.5 liters in this case per day. So next is for the energy storage. So this was the first example for energy storage in publication in advanced materials. This is the enhancement of thermal conductivity. But with this kind of enhancement, we tried to build this. This heat exchange without fins, we're using expanded graphite as a fin because the thermal conductivity is very high. So in this case, it's very easy, and we could create 1 kilowatt system, 1 kilowatt hour system, and then this is a 15 kilowatt hour systems. We just connect it. So it's very easy to be integrated, and we demonstrate. And also by adsorption researches. So adsorption of moisture, it will generate adsorption heat. So in this case, air temperature will be increased. So in this case, we consider whether we could use this as a thermal battery. But usually for thermal battery, what we found there is so-called a reaction wave, and we developed this model. Because the most important thing for this, how to get stabilize temperature output. Because if we have inlet temperature 20 degrees, heated to about 38 or 40 degrees, this is good for room heating. So in this case, we need the control of output temperature and also the control of the output power. So we developed the model and demonstrated and succeeded, and also had 240 kilowatt hour in 1 cubic meter. So this is a very high energy density for the adsorption thermal storage. And then I asked another student whether we could use this kind of technology for the thermal wall, actually for the solar. Because thermal wall normally used during the day for the room heating, but how to use it in the night. So in this case, we consider to put the honeycomb adsorption thermal battery into the wall. During the day, you get the regeneration of moisture. And heated also come into the room, but during the night, so we could get some humidity come to the channel and then absorb it, and then heated air comes into the door. So in this case, we could demonstrate for the all the day usage, 24 hours, with effective heat delivery from low carbon building heating and energy consumption reduction could be nearly about 54%. So we demonstrated the normal thermal wall and also adsorption thermal battery wall, and we tested. So I think when the student is doing the research, try to find a very good topic. So this just based upon my swimming. During my swimming time, I think I got one idea. When I finished, I immediately come to the student. This is your PhD work. I think could be a good idea. Then I asked this student to do, and she succeeded for this research. And also another work we're using atmospheric water harvesting with energy storage. So in this case, we used some hydrogen, and the hydrogen could get more high water adsorption. And so now this student also did a very, very successful job. And based upon this, because in the last years, there are a lot of interest for the radiative cooling. And during this process, I think 2018, I applied one project from the Shanghai municipal government for the greenhouse because they need greenhouse technologies. So in this case, we just using a solar radiation film for the cooling. In this case, to get nearly, this is the excellent cooling effect, nearly about 18 degrees centigrade reduction for the greenhouse to compare with normal greenhouse. So in this case, we are sure that we could use this greenhouse even in summertime with temperature 35 degrees. So we still could use the greenhouse inside to produce plants. So also the vegetables, what you got to compare experiment with the controlled ones, original ones, we have increased the quantity and quality. And also we tried another radiative film and use it as a cooling marker on the ground surface. Because in this case, we try to reduce radiation cooling for the reflection to the other side sky, and in this case, to get the root of the vegetables, to get a temperature nearly about 10 degrees down to compare with regular one. So even the room temperature is high, but the root is comfortable. So this is another thing what we could have done. And this you see with RC, that's an example. Others, there are 3 kind of other films we tested, but with a radiative cooling film as a cooling marker, it's really successful. We tested. Also, get Chinese cabbage yield, nearly about 127% increased. And this paper was published in Nexus, and because I tried with a JOR, and also Nature Sustainability, the both Senate review and the major revision, and then another review process, but the original review do not want to review again, then they invited a new review. New review say rejected, then rejected. So at first, Nature Sustainability. And then to submit it to JOR, we got the same results. So in this case, it cost a long time, and the student wanted to get a graduation. And Nexus is an open access journal, and also SharePlace. So Professor Jelly Yan is just the chief editor for this. So in this case, we published the first research paper in Nexus. And also now it's less than 2 years, but we could get now it's about 30 citations because this is a very good research work. And also for the greenhouses, we demonstrated that even in Singapore, that my students come there in the rooftop because the humidity is high to uptake water from the air and use this water for the greenhouse for the growth of plants. So in this case, we created 1 square meter. This area we did a test about 2 weeks, and we produced 1 square meter, nearly about 880 grams of water, and produced 1.28 kilogram of vegetable, actually. So this just shows example, and another example we published in Nature Water by another student, and we use this kind of high hygroscopic gel for passive plant transpiration and soil evaporation water cycling. So this just got that water saving for greenhouses. We could get the saving nearly about 45%. So then we had some research with heat pump. This is our conventional area. Because other students published, and then heat pump students, they said, Professor Wang, we also need high impact publication. But I said normally it's not possible because heat pump is a very, very mature area. But we tried our best. The first that we developed water vapor high temperature heat pump and utilizing industrial waste heat. And we found water is good substances for the heating temperature output over 100 degrees centigrade. So that's a natural refrigerant, and so also efficiency is high. So we build a system for waste heat recovery from 80 degrees to 120, 130 degrees. So if you upgrade nearly 50 degrees, you get a COP value of 3.5. For 40 degrees, it's about 4.5. So we demonstrated this and also succeeded. And this was published in the 25th International Congress of Refrigeration in Montreal. And big competition. So finally, my student, Woody, in the middle, he got the first place for the student competition. So there are 3 students to receive the award. And another example is the 26th International Congress of Refrigeration in the year 2023 in Paris. Another student, and in collaborating with my engineering PhD student. So they're working for high efficient desiccant coated heat exchanger based heat pump to decarbonize the layer transportation. So this is based upon my solid desiccant dehumidification system to get a COP value 100% increased. And then we succeeded, demonstrate, and now this year it will start for the Lear application in the Metron's line in Shanghai. And also this student is very happy to receive also the first place, the best student thesis for the 26th International Congress of Refrigeration in Paris. So then this student, we collaborate with NTNU, Norwegian University of Science and Technology. So he feel a strong desire to get a publication in high impact journals. So we tried a lot of times. At last we had a research for heat pumps as a sustainable bridge for global heating and cooling at a multi-scale, because we consider something not in a small scale, but at the world scale, and to consider heat pump contributing for decarbonization, not only for heating, but also for cooling. So in this case, this kind of topic could be very interesting for big journals. And then we had another work for heat pump integrated with latent heat energy storage. Now we developed the whole models, and it's sponsored by a big project from a National Natural Science Foundation of China. We try to integrate heat pump with thermal storage. So in this case, we could take industrial heat or heat from the ambient air by heat pump, and then get it stored into the latent heat. So you get nearly 3 times or 4 times increased. And then with this, we could use another heat pump, even increase to the industrial heating demand needed, or cascaded heating for the normal uses. So in this case, we got very, very flexibility for the uses of PCM materials. We select high density, safe, and cheap materials, maybe 60 degrees centigrade, for example. So then it will be easy for the market to accept. And also we had some tests for the intermediate thermal storage because some areas, summer heating, winter cooling needed. So if we consider thermal storage, you need to consider heat storage and also cooling storage, cold storage in summer. But in this case, you need to double 2 tanks. So finally, we consider to have an intermediate thermal storage at about 15 degrees to 20 degrees. But we use heat pump, in this case, combined together to solve the need during the winter heating and the summer cooling. So in this case, all the year operation, we could get more high efficient. And also, we try this to consider with integration with the direct air capture. And the direct air capture, because they are also considered with the adsorber and the desorber, but adsorption process, you need the cooling, desorption process, you need the heating. So originally, it's a separated system. Now, we propose to use heat pump. And this heat pump, so the Professor Tian Shuge, she's here. So she was responsible for this. This is a demo for nearly about 600 tons per year CO2 direct air capture from the air. So this is actually the first demonstration that we could see. We have the technology for negative CO2. In this case, now I think next year we will have more bigger systems for the demonstration. So finally, I say something about solar-based desalination. So just the first figure is a collaboration that we had, the first publication in EES, actually in collaboration with MIT, and also it was selected as top MIT research stories 2020. So we using thermal localized multi-stage solar stir, and what we generated, solar GOR, so nearly about 385% because solar energy could be used with a multi-layer, with multi-stages. And also 1 square meter per hour, you could create 5.78 liters of fresh water. So this is really the high productivity. After that research, also we consider the uses of extreme resisting multi-stage solar desalinations with thermal hollowing convection. Because if original ones, we're using some capillary effect to get the water from the sea and then heat it with the solar. In this case, you create some salt crystal, and then you had the problem. But later we had a new concept for thermal hollowing convection. In this case, we could get continuously flowing and using gravity, this kind of feeding process. In this case, get even salinity needed 20%, we could get 1.8 kilogram per square meter per hour. And then also other papers for solar evaporation with solar replacement to the real-world applications. We could create the real system that to get fresh water very, very cheap in this case. And also we demonstrate multi-stage MD solar desalination to get 9 liters per square meter per hour. So that's all that our researches from 0-1 and 1-100. So this research, we have some results. When the results have published, we got a lot of news that this makes every researcher very, very happy because even Chinese government, the central government published the news for our research because the news was from abroad. And then they said, oh, Chinese scientists, they did this work and published in central government news. And also we got a lot of the basic paper award from SDEWES for Chinese every year. And this is for the 50 years anniversary of SDEWES. And we filled the table. Finally, we had a lot of high impact publications. And also the laboratory is much better. And more publications, and we selected there. And also we expanded the laboratory for the more possibilities, in this case, to attract more fantastic researchers. But meanwhile, we did for atmospheric water commercialization. We innovated a company so-called Atmosphere, because it's atmospheric water harvesting. Where is water to get water? So it's sponsored by General Electric Water. So it's they got 51%, our team 49%. In this case, now we have a demonstrator so-called Itawa Park. And so this park, because we had a lot of unit of this kind of prototype, now it's on the way of commercialization. So this is actually the commercialized product. So not only for the room side, but also outdoor units. And meanwhile, we published one paper, commentary for JOR, because we contributed for the review and also for the perspective. And now I think it's time to give a commentary for the approaching thermal boundaries and how to solve the problem of atmospheric water harvesting. So in this case, I would like to show you a very short video for this Itawa Park, and we try to demonstrate what kind of things there.
Itawa Park, a zero energy park. Here I could show you innovative researches on energy, water, air, and food nexus. So here we see it's a green energy laboratory sponsored by Italian government. So it's we call it Italian Green Energy Laboratory in Shanghai Jiaotong University, which is equipped with about 60 kilowatt photovoltaics. So now we already connected this to an electrical battery power station. Here you see this is a 256 kilowatt hour battery, and which is used to So welcome to visit. Itawa Park, a zero energy park. Here I could show you innovative researches on energy, water, air, and food nexus. So here we see it's a green energy laboratory sponsored by Italian government. So it's we call it Italian Green Energy Laboratory in Shanghai Jiaotong University, which is equipped with about 60 kilowatt photovoltaics. So now we already connected this to an electrical battery power station. Here you see this is a 256 kilowatt hour battery, and which is used to store the energy from the photovoltaic of the green energy laboratory. So in this case, we could gate this green energy laboratory as an off-grid building. Meanwhile, we have another demonstration of off-grid. This is a container box building, and which is shown here. So it's also, the roof is powered with the photovoltaics, but we have also electric battery and also air conditioning. And also here you see the air conditioning inside, but we have also battery stored there for the storage. And we have atmospheric water harvester to produce fresh water from air. So this just shows how a container box could work with only photovoltaic and so electrical battery systems. So this is a second actually off-grid building. We had a third off-grid building actually is here. And because we use this, also photovoltaics with heat pump systems, but also we have the battery inside. So this is actually used for the rooms. So with photovoltaic batteries, and here we have the battery storage, about 10 kilowatt hour, and this is used to support the whole building here, a small building. And also we use air conditioning. I call it as a small temperature difference fan core unit, and which is driven with air source heat pump heating system. So it could be used for winter heating, comfortable heating, and also summer cooling for air conditioning. So meanwhile, this building is equipped with a lot of facilities with clean water for the drinking. And this is a normal clean water drinking, which we have the tap water, and you have get purified water for drinking, and a coffee machine, and so on. But what's important here, I want to demonstrate. This is actually off tap water. So it's an atmospheric water harvester. So by this machine, every day we could produce about 15 to 20 liters water, actually. So we could use this to put anywhere. If we have the electricity supply, then you could produce water. And here we also show a building outside. So this outside building, and we demonstrate, this is actually food nexus, a container box, also powered with photovoltaics. And but inside we have plants just growing inside, because we're using artificial lighting for the power to simulate the sun. So here you could see that what inside it's rotating of the machines and try to get so very good equivalent sunshine for the inside of the container box. So this, we use it for the food processing, but for the food processing we need water. So we have also this kind of system, so called atmosphere, and this is a container we're using desiccant rotor. That's atmospheric water harvesters. So just using this water and come into the building, and also the building inside, we have another atmospheric water harvesting, just using condensing unit to make just the recovery of moisture water inside. So in this case, this just forms so-called innovative team for energy, water, and air nexus. So we use this as a demonstration as a small park, but also we have 4 independent off-grid buildings. We're using photovoltaics and also batteries. So in this case, we had China, Italy Green Energy Laboratory, and also small container box. And here is another container box for the food nexus. And also here, we're using this as a small conference rooms, also supplied off-grid with photovoltaics. So this is also just a very good demonstration to show how in a campus we could have so off-grid systems. So actually we have 4 off-grid systems that are working together to show zero energy park or zero carbon park. So I hope this demonstration will be fruitful and to have a lot of achievement, and we could get more applications of this kind of systems.
So finally, I think here still. Yeah, okay. To open. Yeah, it's okay. Okay. Okay, so in this case, our teams is growing up, and there are 4 faculty members, and there are some students, and now some students become faculty members also. So year after year, we are increasing the number, and also we see the changes, and also several young faculty members become the selected national level talents. And also my team, actually is a big team, that's all the faculty members and in my working group. But most of them is not for the Nexus. That's normal refrigeration and cryogenics. But for the Nexus, only 4 professors involved. And so the group is going up, and so we are very happy with this research group. And so we have a very good basis for the Sino-Italian Green Energy Laboratory and supported by Italian government. And we had a lot of collaboration also with the Italian universities. So this is actually, finally, we have also mechanical engineering-based laboratory there. There is a much bigger than Green Energy Laboratory. So finally, Mark, so energy, water, air, food nexus, that's a very good area. This research should let us understanding from 0 to 1 and also 1 to 100 paradigm. And the most important thing is to inspire young researchers and teamwork, but we need to excel in pioneering innovation from 0 to 1, while try to scale up from 1 to 100. So we are doing our best to try to do this, but I think this is a research story as a professor, how I work with young faculty members and also the students. Thank you very much, and this is Shanghai. So you are welcome to visit Shanghai during the day and during the night. Thank you very much.
Thank you. Thank you. Sorry. Okay. Thank you, Professor Wang, for the very comprehensive and stimulating overview about these technologies that make these different levels interact one each other. We are, of course, almost in the lunch time. Just time for a quick debate, a couple of questions, because there are a lot of stimulating points. Please, Professor SDEWES.
Thank you for overview of really very exciting research. For me especially, because I had the opportunity to visit your impressive lab. We are going to need a lot of water to green the dry areas. And I was wondering, did you estimate the potential of harvesting and multi-stage processes in delivering that? Because with the current system, which is mostly used, reverse osmosis, there is a problem of flexibility. We have lots of very cheap wind and solar electricity in some hours of the day, but solar desalination with reverse osmosis should mostly work flat. We could solve that with batteries, but it would be better if we could have a variable desalination system or harvesting system.
So normally, I think in the seaside, or even some desert area seaside, so we would propose to using condensing unit because it's a more cheap, more high efficient. But there are still a lot of requirement for if the area is far away from river or from the sea. So in this case, atmospheric water harvester using adsorption or liquid absorption systems. So now we already invented some adsorption unit and also desiccant route system to get about 50 liters per day. And meanwhile, we already had another type for lithium bromide water or lithium chloride water, liquid solution for the absorption water from air. This is more high efficient in combined together with heat pump. Currently also we built a 50 liters per day unit. And so we expect that we could build in the future just upon the demand because technology is available. The most important thing we try to make it that how to get the payback period. If it's less than 5 years, it's easily to be commercialized. If it's more than 10 years, it's no possibility. So in this case, we need consideration to select most advanced materials, but it must be economical, high sorption performance, and also high stability. So in this case, our research laboratory, we had a lot of collaboration with the material people, even for the joint publications, and now we are considering, we taught the material people to not only give high performance material to us, we also need cheaper. Maybe cheaper one, but the performance is lower, but maybe more easily to be commercialized. So in this case, such as our publication in JOR, we asked the material people to consider our requirement because finally, for the commercialization, we have several boundaries to overcome. Thank you, Never. Yeah, thank you.
Another quick questions?
Yes. Hello? No, it worked. My name is Eberhard Waffenschmidt from Cologne. You showed a slide where you improved the growth and you cooled the soil. Have you ever considered improving the soil with pyrolyzed wooden coal? Because in that case, you would improve the possibility to save water, and at the same time, the coal would reduce carbon from the atmosphere.
Yeah, that's a very important issue. If we use this for the growing plant, if we get water, because I had experience when I visited Middle East countries, Kuwait, for example. So along the airport to the city, they're using spray of water to get green plant. So everywhere is green, but consumes so bigger water. So if we take water from the moisture, it's a little bit expensive. So normally in this case, we proposed to use hydrogen. So hydrogen actually to make the water to be captured by the hydrogen and in the root of the wood materials or plant. So in this case, water will be freely to be distributed. It's absorbed there, but the plant needed to use the root to take water from there. So in this case, we could save a lot of water in this case. So I think a good engineering, final research work, we need to consider a variety of technologies integrated. So these kind of things like hydrogen should be used for this kind of very specific agriculture. Thank you very much.
Okay,
thank you for the answer.
I would probably, because of time issues, leave any other question to the lunch time, and so I will greatly thank Professor Ruzu Wang for this excellent presentation. Thank you.
Yeah, thank you very much. Thank you.
And so please join the lunch now. Thank you.
Just need to stay with the blood. I did.
We need 2 more minutes, the technical guys say.
That's good because I have to check if I turn off my mobile phone, otherwise it will start.
Okay, you can,
okay, so I'll check.
You can do that.
Yes.
Ona tamo, da. Dobro. Dobro. Čekam. Da.
Čekam ova imena, budući da sve piše kako hoćeš.
We still wait for the technical guys to connect. Sorry? Patrick is online. He is on Zoom. Yes. Yeah.
He's from France, isn't
France, yes. He's too big guy to be able to bring. Yeah.
Too big in the sense of too important.
Too
not
important.
Too big,
Yes,
like
yes.
it doesn't fit in the plane. It's
No,
not.
no.
Oh, it's so big that it cannot fit there.
Yeah. No, but I think it's very valuable because we were working together on an e-mobility report by KITES. This is the Council of Academies of Technical Science. So he did write this chapter, transition of automotive industry.
So I just have 2 or 3 slides. It's like
Sorry?
I just have 2 or 3 slides. It's like
Yes.
3 minutes or something,
Okay.
just and then you can discuss whatever.
Okay, good evening. Let us start with our last session today, a panel on Draghi report and Europe's industrial transition amid transport electrification. Does the EU have an industrial future? It's a relatively big question, but I think it's important to open it here because we see the transition is coming, but the industry is afraid of it very much. So we will have panelists here. Paula Ferreira, who is Deputy Editor-in-Chief of Energy, covering economics and energy issues, energy economics. Also, there is Ingo Stadler, professor from University of Cologne, Technical University of Cologne. And then Reinhard Haas, professor from University of Vienna, also energy economist. So we are here 2 engineering guys and 2 economists. And then we have online Patrick Pelata, who worked together with me on the KITES report on e-mobility. He is a president of French Academy, National Academy of Science, and he was also a very important person in French car industry. So he will bring us his a very insightful view of the transition that we are in front. So we have 2 questions here. One is we see the transition coming, and the other is how to make it actually work. So I would start this with my initial slides. If you can put my slides on. I will go to control the slides there. Okay, so one important thing to say, Europe is falling behind. Out of 50 top 50 companies, only 8 are European. Out of 25, 0. What happened? We used to be the center of global industry, and nowadays it all left somewhere. There was a recent Draghi report which gives us advice on the key pillars of the industrial strategy that the EU needs. And he mentions integration of decarbonization with competitiveness. We have to do it together, not a separate thing. It should not be a cost, it should be opportunity. There is need for massive investment like other countries are doing quite successfully. Europe has to do it on an EU level. We need all kinds of mechanisms that will help innovation and clean technology. Horizontal actions, we need better coordination of industrial competition and trade policies. We need streamlined regulation to reduce fragmentation. We need vertical actions like sector-specific strategies for industries facing global competition or decarbonization challenges. And we need to support EU champions because it seems it doesn't work without it. We have to close innovative gap with the US and China, and we need to promote technological sovereignty in critical areas. We need to invest in greener digital skills. We were pioneers in green technologies, but what happened? Also, we need to reduce dependence in energy, raw materials, and technology supply chains. On the other hand, we have in CAIDS, which is a global council of academies of engineering and technical sciences, we have done in 24 a report on the current state and future path of energy transition in the transport sector. And our conclusions are that there is need for joint effort from industry and research for the whole value chain. We need to integrate power and transport sector. We need smart charging. We need market coupling. The car industry is already being transformed towards EVs. E-fuels will be competitive probably, but only with maritime and aviation transport. Developing countries have opportunities to leapfrog, and the fire hazard of EV is not higher than internal combustion engine, but it's different. So my questions for this panel are, why are we slow on digitalization? We can see here what happens in developing countries. They are moving very quickly. Nepal had 75% electric car sales last year. Europe is behind Nepal. Why? What happened? Digitalization, we are slow on electrification, and it doesn't make sense because Europe doesn't have fossil fuels. Why don't we actually see that we have lots of renewables, electricity, and we should quickly move towards electric cars? We are defending markets with fake environmental standards. We're still fighting against petrol and diesel car sales ban in 2035, not 25. What will happen to European car industry if ban is removed or weakened? Can it compete against cheap electric cars in Africa, South America, and Asia? We're losing those markets. If we remove the ban, Europe will stay closed like a fortress, but we are going to lose most of other markets. Ethiopia example, it just banned internal combustion car engines imports. and it had 60% sales of EV last year. Can EU withstand populism? We are hearing from populist politicians they're against electric cars, but the price for following them instead Draghi it will be terrible, because we will, in my opinion, lose the competitivity. So thank you from my side. And now I would like Patrick to give his initial pitch, please. Can we hear you?
Okay, that's it. That's it, sorry. Yes, so thank you, Nivan. And I agree with the slide you put on automotive industry, the conclusion of last year CAET's report. Yeah, industry auto is very big in Europe. It's like 8% of GDP of Europe, 8% of the jobs. It's exporting 90 billion euros trade surplus. It's 1/3 of EU research and development. But it's also 24% of the CO2 emission of Europe. And if I look at the evolution since 1990, it's plus 22%. If I compare with the rest of the economy of Europe, the EU 27, EU 27 except transport has done minus 47%. And automotive, plus 22%. Transport with aviation and maritime has done plus 27%. So this is, you can understand why European Commission is pushing for very strong commitments of decrease by the automotive industry, at least for new sales of cars. So that's the context. The industry is scared of that. Is scared of that and tries to push back on 2025 first target of minus 15% against 2021, against the 2030, which is minus 55% against, this is CO2 emissions of new cars sold, and of course against the ban of thermal cars, thermal engines with in 2035. So when we look at the technology is okay, it's there. Cost is decreasing on batteries, and it will decrease as a result on electric cars, because the rest, power electronics, electric motors, costs are not so high, even lower than the rest. So I would say without the battery, an electric car should be lower cost than a thermal car. So technology is there. The movement has started, could go faster, but the industry is scared about that. So they are asking more charging facilities. This is, I would say, going on pretty well, except in part of Eastern Europe. It was late in Spain and Italy, but it's catching up. So this is fine. It's not fine for heavy trucks or utility vehicles. It can be improved, but again, there's no technology issue behind that. So the second point that the industry is scared of is China imports. And I will come back on this point, because it's part of the responsibility is also the automotive industry in Europe. But there is one point on technology that is missing, it's batteries. When China, Japan, Korea started to accelerate very strongly on batteries, this is in 2003, precisely. And then they went further, further in 2008, 9, 10. And then we could see first Tesla, first Nissan, first Renault. I was part of that in 2011, 2012. But in China, 10, 12 new cars, electric cars, among them some cars from BYD, now the #1 player for electric cars. But at that time, Europe did nothing. Nothing. This is a lack of vision. This is a lack of consequential thoughts about what global warming and the struggle against global warming would mean for road mobility. It was very technically, scientifically very clear, but Europe did nothing. And of course, 15 years later, industry has been built in Asia. They have economy of scale. They have acquired a lot of know-how, and this was not in Europe, even though the advanced research had been done in Europe, both on lithium-ion, nickel, manganese, cobalt, and on iron phosphate. So this is a big mistake from the beginning, and of course this is roughly, I'm speaking there of the cells, the rest is easy to do in Europe. This is 1/4 roughly of the car cost, so it's substantial. So this special mistake needs to be fixed, and when you do mistake, you have to pay a price for it, and we have to accept to pay this price for a while before catching up. The second point, I'm coming back on it, is China import. China has economy of scale because they developed today it's roughly 1 car out of 2 in China is electric. And it's a very big market, 20 million cars roughly, bigger than, a little bit bigger than the European market usually. But 50% that makes economies of scale. So now in China, many players have platforms above a good threshold for economy of scale in automotive is 500,000 cars for 500,000 platforms. Many players in China have that today. And this is big, big, big cost reduction. Tesla has 2 million cars in 4 plants on just Model 3 and Model Y, which is the same platform. This is a huge economy of scale. Nobody in Europe is close to that. Nobody. So slowing down, asking to push back on 2030, even 2025 or 2035, is just decreasing the speed at which the market and therefore the volumes will catch up and the economy of scale will come. So in this attitude, I really believe today that car makers are making a mistake by pushing that back. The second reason, they are saying cars are too expensive, but they made expensive cars. Cars could be much cheaper. We start to see now a few cars, electric cars, at much cheaper price. And in China, you have today electric cars, reasonable electric cars. Some of them will come to Europe at $10,000, $12,000 with less VAT in China, but still that's like 15,000 euros. It would be very affordable. And we can also rent the batteries, lease the batteries to decrease the visible price for the customers. All this could be done, but has not been done so far. So this is what's missing. So in short, what I can say on this introducing pitch is this revolution is a tough storm on automotive industry in Europe, which is a big thing. Number 2, it's mandatory. And number 3, slowing it down is going to slow down the fact that car makers and suppliers reach the right economies of scale, a better cost, and therefore more volumes, more customers stepping in, and Europe going faster to its target of net zero for 2050.
Thank you, Patrick, for your initial pitch. I would ask now Paula. You have slides, so maybe it will be easier if you do it from on the stage.
So firstly, thank you for the invitation to be here. And just a short disclaimer, maybe it's just to start, and I think it helps to explain the vision that I was bringing here, is that I'm not an economist. I'm an engineer, but I believe that in the core of the engineering decision-making, we should have the society perspective. So we should be developing technologies that at the end of the day will be serving the society in the best way. So that's the idea that we try to bring in our research center also, is this idea of merging social perspective, economic perspective, and technology decision-making, that I also believe it's also a bit on the core of this Draghi report that we discuss, and this need that Neven already brought to us, this need to close the gap that we have with China and the US of technology development, but never lose track on this aspect of the social inclusion. And also the same aspect with the decarbonization, which should not be a cost, as Neven said previously, but it should be seen as a source of growth for us all, and especially for the European. And of course, we have the problem of the security of supply, that we are all very well of this, especially in the last years. I think it's more or less common sense, the problems that we have with our dependence on the critical raw materials and technologies. So I would say that the idea is that we must ensure this productivity growth, this competitiveness, this clean economy, always align with the perspective of social justice. And a clear example of this is the electrification of the transportation sector. And we should be aware that maybe if you look at the supply chain, we can think of 4 main elements there. And we are frequently highly focused on the two ones of the middle, which are the manufacturing and the operation, which are very common to have here in Europe. But we also have the initial part, which is the mining and the refining, and we have the end of life, which also must be part also of the European perspective. We cannot focus only on the manufacturing and the operation. We are now very well aware of this resource critical moment that we are living, which is highly related with the mining, refining, and end of life. But there is also, that brings us also the problem of the social justice that is surrounding each one of these steps in our supply chain. And I have here a graph, which was not designed by me, it's from Hawaii. She's there on the common work that we are doing. And I think it's a nice graph. It has already some years, but it remains more or less stable, which is this idea, if you look at it from a global perspective, we can clearly see where the mining is taking place, which is usually in the south. So it's basically Africa, it's basically South America, also of course in Australia, and of course in China. China have everything, it has mining, refining, end of life, using operations, so let's forget about this. But basically that's what mining comes from, is from the south. And most of this mining, for when we need to refine the materials, we do it in China. Now we are trying to improve a bit our skills in here in Europe, but we are still very, very far away from this Chinese development. So basically we bring our minerals that we extract from the south, we bring them to China where we do the refining. Now again, trying to do it also in Europe, but still very far below the other countries. And when this process is ended, now we bring everything to Europe where we assemble everything, and we have our automotive industry where we build our cars, and also in North America, and where we use them. And when we get to the end of it, so we used to send them also abroad. So when we have the end of life, we tend to send them abroad. That's something that we are trying to solve now also in here in Europe, especially because of the raw materials, because actually at the end of the day, when we send our end-of-life vehicles to other countries, especially China, we are losing track of all these materials again. So from the economic perspective, it's something that shouldn't be done. And from the social perspective, it's also something that a bit we lose the track of it, which is also very far away from configuring kind of a social justice perspective that we claim. But also, this justice is not only related with this the first and the last segments of the value chain. Even for when we talk about the manufacturing, the use, we also have some injustices in this process, and we have here some examples, and we already mentioned them. We have the problem even in the use of the electric car, which is still, although Patrick already mentioned, the cost that is being reduced now, that we should try to reduce it, but it's still seen as a kind of an elitist market that is always for a certain group of people to have access to it. And again, this configures another social injustice that cannot happen. So it's something that is also relevant, and when we develop the technology, we must think that the technology must fit, again, the purpose of the society, and we must think that it must help us, all of us, to develop. And this is related, for example, with energy poverty, again, in this case on the use of the electrical vehicle. And these differences between the north and the south that I already mentioned, these differences between the urban areas and the rural areas that tend to develop a little slower. And so this is creating a lot of cleavages, which is absolutely against this idea of the European, which talks about cohesion, where we should always look for cohesion, and we should make sure that at the end, the development of a certain technology will not create additional cleavages between all of us. And I truly believe that this is possible to be done. We just need a finding way of designing our models, and that's where I work mainly. It's on the planning and modeling perspective, and we should develop our models, our planning, our policies, and in particular with technologies with a sense of inclusiveness. So we need to be competitive, and we must make sure that we don't lose this cohesion that actually is the backbone of the European. And so with the final question that is a bit related with the initial question of Neven, but I just included another word there, is as, does the European Union have an industrial and inclusive future? And so it's a bit a correction to the question that we may want to discuss. Thank you.
Thank you, Paula. Ingo, if you could have your initial point, pitch.
Okay, thank you, Neven. You have been inviting us to discuss the Draghi report, especially in the section for transport. And I think, as we have seen on your slides, with most things, we only can agree. But there is one point I absolutely disagree, and that is what I would like to make my first point here, and that is that Draghi reports on many pages always on technology openness, technology neutrality. And there is my opinion that that is not a time where we can go in all directions. And in order to make that a bit more clear, I would like to tell a bit of story. Let's assume just for the next few minutes history would have been different. Let's assume the last 100 years we would have gone with electric battery-driven cars. And now there's someone coming with a revolutionary new technology. And I have a great deal for you, maybe the greatest deal humans ever made. I have here the gasoline car for you. It comes with hundreds of moving parts, oscillating 1,000 times per minute. It shakes, it rattles, it breaks. But don't worry, your local technician will love you because you come often to him. And then for recharging, you cannot do that at your home while you're sleeping. We have specialized filling stations where you need to go, you fill your car with a highly inflammable liquid in a single-walled plastic tank. It has a bad smell and it's poisonous. And every 1,000 kilometers, you need to go to change the oil, to change the filters. And we also have implanted new technologies like gearboxes. You also need to maintain a great technology. And even so, it is so complex, the efficiency is so much worse that most of the energy will convert it to heat. Hey, it's so great, you never will be cold again. And then the final feature is when you drive, you spray out a fine cocktail of carbon monoxide, of nitrogen oxides and small particles that cause cancer and they go directly to the lungs of your children. But now it's coming to the real selling point. You can go much farther without stopping than with these old-fashioned battery cars. And isn't that advantage not worth with all the noise, the maintenance, and the slow poisoning of ourselves and the planet? And I think when we look at it a bit from a different perspective, when we really assume we would have had battery cars and now turning to this new old technology, I think it is so clear that even in a lawnmower, you would not get permission to implement the internal combustion engine. And I think there is reasons why there is so big resistance against battery electric driven cars. I think we can discuss about later, but that is the reason why I strongly oppose Draghi's report in this technology neutrality. Thank you.
Thank you, Ingo. You're always great at giving the point. Reinhard.
My first and most problematic issue is, are the conditions for the energy transition really clear? The policy boundaries, are they clear? Or are they too much, too many, different? And what is transition? Transition is to go towards less carbon emissions. In the electricity sector, it is to go towards renewables. We go towards renewables and not to nuclear. And the transition in the electricity sector with respect to mobility has been explained already right now. So what you have said, Nevin, there are so-called fake environmental standards. And this is from my side correct, and I think there's also no really 100% commitment regarding the ban of the ICE vehicles. It's also to some extent under construction. If the policy in the EU changes someday, tomorrow it can be different. And so in the Draghi report, it is said we should have more private, more public capital. But if the conditions are not clear, you will not raise at least no private capital. You have to have the clear conditions, a playing field. And if we talk about policies, I think a very clear policy would just be to have a predictable CO2 tax over the next 10, 15, 20 years. Then the industrial companies can see what they may expect and have their actions correspondingly. Another issue is energy costs. It's also addressed in the Draghi report. So we know in Europe we have quite high costs at the final customer level. I think in the average in the EU we have at least a double price that exists in China, and these high costs in Europe have different reasons. And one reason currently is that we have to reconstruct the infrastructure. That is to say, 5 years ago, I think we had still the infrastructure we had 60 years ago. The grids in Europe have not been really upgraded in a, let's say, reasonable way. We know the problems in Germany with the whole infrastructure, from the railways to the ship or bridges and so on. So this is one part in Europe that has been neglected for a considerable time, and there we also have to find now ways to provide a modern structure. And with respect to the, for example, car industry, the difference China and EU is China is building up, let's say, an industry is building up a corresponding infrastructure. But in the EU, we have a reconstruction. We already have infrastructures, and now these infrastructures has to be changed. And maybe two last points. The industry in Europe, the car industry is highly linked with tires, with the steel industry, and with some other industries. And how do these industries change? I know it from Austria. Our largest steel company is going towards innovation. Our largest steel company is about half of the European, half of the Austrian overall industry. But I have just heard in Hamburg they have tried to switch to hydrogen for steel construction, and this project has now been abandoned. They do not do it anymore. And the last issue is now Europe versus China. I think last year, about 65% of the electric vehicles worldwide were built in China. I think about 18% were built in Europe. And I think the issues that we could export vehicles, electric vehicles to China is rather small. But at least there was some article recently on the German company Audi. And Audi has managed to become a player in China. They are competing successfully with Chinese companies. And Audi is now, let's say, bringing back the new philosophy to Europe and trying also to revive their company in Germany.
Thank you very much for the first round. Now I will have some tough questions. So I start with Paula. Regarding justice issue, we have many people employed in car industry, and many of those people will lose their jobs because all these spare parts that Ingo was mentioning, thousands of them, will not be needed with electric car. Also, petrol stations will not be needed. Oil refineries will not be needed. That's many, many jobs servicing cars, because electric car doesn't actually need to be serviced that much. These are going to be lost. So on one side, it will be very bad transition for some people. There will be, of course, new jobs. We need to digitalize car industry, to move to offer new ways of charging, etc., etc. There are many new jobs there. But the problem is this, that lose job, they lose jobs. This is one option. Can we actually be kind of have just transition for them, teach them how to program, or find them different jobs? Or if we protect those jobs too long, we are going to lose car industry, and then there will be no jobs. So how, from the justice point of view, you solve that conundrum?
Okay, so there isn't any direct answer to this, as you may imagine. It's more a discussion, and you can find, if you look at, just Google it, you can find thousands of studies about the creation and the destruction of jobs from the electrical vehicles. So you can find any study that fits your interest. You can find a study showing how the jobs will increase a lot and it will be fantastic, and you can find studies showing that it will be a full disaster. So there isn't, that's the first issue. There is a lack of clear studies and with no economic interests behind it that actually show at the end of the day what can we expect. It's not easy to be done, especially because we don't have any historical background to support us. But the studies that we find, not all of them, but a lot of them come from different associations or institutions that somehow can have some interest on this. So that's the first one. The second one that you mentioned, and it's clear related with this justice, not only on the quantity of the jobs that may be lost or that may be created, but on this quality of the jobs and where will the jobs happen. So there is, I don't have the exact numbers, but more or less like 2 or 3 years ago, I saw a study that showed the numbers that are official, that show that about 20%, close to 20% of our workforce in Europe has more than 50 years old, which means that, okay, I'm not going to call old people because I'm also there, but, but it's very difficult for these people to change the way they work. So one thing is to have people in their 20s and ask them to change their perspective and to change their jobs. Another thing is to ask older people to do it. And that's a major problem that I would say, and this from the justice perspective, that is something that I think it worries me and I don't know how to be solved. It's the age of the people. And you cannot ask someone with 55 years old that now works in maintenance to start working on mining extraction or in digitalization or whatever. And this also creates additional problems, which is this transition is also related with digitalization, as you said. And so it's a services economy, not as much as a manufacturing economy. And again, this creates this lack of cohesion that we like to see in Europe, where we traditionally would see manufacturing companies installing themselves in regions with lower wages, for example, and at the end of the day would contribute for the development of this region. That would not be happening if you have a service economies, because people will not be sending their companies to locations where they don't have the proper job workforce. So I didn't answer anything, as you could see. So I don't have any answer, I just have questions, and I think it's something that should be taken into account when we design policies like this one, like this idea of changing everything until 2035, because we need to see how actually this will impact the way we live now.
Patrick, digitalization is, in my opinion, a crucial step in moving towards electric cars. But European industry is not doing that in a best way, I would say. Whenever I rent European electrical car, I get a car which doesn't have integrated navigation software with state of charge of battery. For me, this is the basic part of an electric car. But when you rent a Chinese or American electric car, it's of course part of the basic model. How can one even think about selling a car without this integration? You know, of course you can have Android Auto put the navigation software on your screen, but it's not integrated with your state of charge calculation. So I have to plan. I don't want to plan. I just want to drive. I sit in Tesla and I go to Nordkapp and I didn't have to plan anything. But why European industry didn't understand that electric cars are actually infotainment, digital platforms, and this is the main selling point of them.
Yeah, so Tesla as a company is digital native. So they are made by people, especially the boss, who started in digital. I think in China, a lot of companies are like that too. And that's why, and their customers are very hungry about digital services in the car, which pull the car makers into being better at that. This is different in Europe, and that's why we need to take different roads. So one road has been to rely quickly on Google. So Volvo did that, Renault did that, and and that's why the systems are pretty good, because just using the full integration with Google, which also allows some integration with Apple on the iPhones, and then you get this kind of services. But the basic problem is what I said at the beginning: is you have on one side Tesla, a digital native, so thinking about that from the very beginning, and on the other side Chinese, for which on which a few players are also digital native, Xiaomi, for example. But the customers are so hungry that they have been pushing the industry to be really good at that, and that's the important point. I think it's coming. It will come. I've seen Mercedes doing that, BMW doing that. I think this is currently, I believe, coming. Volkswagen made big efforts to hire. I think they were putting 10,000 people in, but they are not software makers. They are not, especially operating system makers. So that's why it's slower. I think it's coming though. Right now, it has been slower, but it's coming. Let me come back on another point, which is what we can do with jobs. There is the potential of training people, whatever their age is, should not be neglected. There is a big program in France of like 4 to 5 billion euros about retraining people for new new jobs. I have been using that for a battery plant that I've been advising on in north of France for 1,000 people, and frankly, it's working. It's working. It's impressive. Even I've seen women that were out of work for a long time coming back to the industry in a role which is a lot of observation about being rational and having memory, and they are doing the job now, and it's working. So I think we should not underestimate the programs that can retrain people. And the last point I want to say about the jobs lost, just think about 1900. Okay, cities were full of horses. In the countryside, there were only horses to move. Half a century later, that's done. All the jobs linked to the horses, carriage, and so on, all that has disappeared, and we created automotive industry, and Europe has been pretty good at doing that. So it took a long time, and we don't have half a century to do it. We have 20 years to do that. And that's why we just need to go faster and use any mean we have to make it. And my last point is, what will happen if we slow down about social justice? What will happen? Global warming, storms, heat waves, people less protected against that, surge of water in conditions with, remember, Valencia in Spain, 250 dead people, a few billion euros of buildings destroyed, infrastructure destroyed. So social justice is also about containing global warming. And we have also to keep that in mind about inclusivity. We need to protect people against global warming, but we need also to slow down as much as we can, as fast as we can, global warming. And it means electric cars, electric trucks, quickly.
Ingo, Germany is a country which is famous for its cars. But the German car industry is very much afraid of the transition. I've been to many different forums and committees, and usually German delegates come with kind of calls for slowing down of the transition. You are from a place which is relatively close to the heart of German industrial zone. How do you feel that the population is feeling with this transition? Also, it seems that the extreme right votes are growing, even in the West. And extreme right is also pushing these anti-transition arguments. How do you feel that German society, industry, people will manage this transition? Will they?
First of all, I would like to defend the European car industry. I drive a Spanish Cupra, and when I tell it I want to go somewhere, it includes all the charging stops, including Tesla superchargers, but many more. But now for your very German question. I think it is always easier when you argue from a country perspective where car industry has not a big role, then transition is easier to go with. So the German car industry is about 4.5% of the overall German economy. And when we look to the producing industry, it is almost 1/5, it's 20%. So there is a big fear that we lose a big part of this 20% of the producing industry. My opinion is exactly what you said in the beginning of this podium here, that when we don't do it now, we in the end will lose more. But for sure, this change is a fright for so many people. I think car producers itself, they might more easily do this shift to the electric cars, but we have so many small and medium companies producing and selling to car industry all those small parts. For example, 2 weeks ago, Bosch has announced to stop 13,000 jobs this year, and most of them in Germany, and that is in the mobility part of Bosch. So there's a big fear. And now we can ask ourselves why politicians are then not doing what is the right way because they want to be re-elected. And this is a quite high share of people who will maybe then not elect. I think it's always difficult, those changes.
It is. Reinhard, why don't we learn from China? You mentioned China. China has, it seems, quite good industrial policy. It's very competitive. Only the best survive. But it mixes subsidy with the market. And it seems it works. It's producing very quickly excellent results. Why can't Europe invest, like the Draghi report is asking, substantial amount of money in this transition? I mean, car industry cannot obviously do it fast enough, but Europe, as richest part of the world, probably could.
I think there are two major arguments. And the first one is, as I said before, China is mainly building up new things, building up a lot of skyscrapers, building up railways, building up and building up also the car industry. So this is different to Europe. China does it because it is currently in a very good economic position. It is prospering. They have skilled workers and they are not too expensive. And the second important thing, which is even more relevant, is in China the boundary conditions are clear. You may say what you want against, let's say, Chinese president, but he has a clear strategy, and this is something we do not have in the EU. In the EU, we have still fights between different countries and between different politicians. So all companies in China know quite clear what are the boundary conditions if they invest, what are the policies if they invest, and that is making the life for investors quite much easier. And there was one more issue regarding China. As I said, they have currently the opportunity to build everything, let's say, on the green metal. In Europe, this is not possible. And then the so-called, let's say, not in my backyard symptom will also not happen in China. No, just one example, in Europe you have to make the transmission lines under the earth because people do not want to see them, and this is 3 times more expensive than if you would have the other structures. So the democratic issue might be less in China. So we have to think in Europe how we can really come forward with our democratic principles. That's it for the moment.
Paola, European economy is growing relatively slowly. Such a transition, would it make it faster or slower? Macroeconomically, how do you think this will impact European economy? Let's say if we apply Draghi's advice, and it seems we are thinking about doing that, putting a lot of money on quickly moving to new technologies in transport. On the other side, we would have this cost of losing old sectors, old jobs.
Yeah, theoretically, we can imagine that providing more money to these technologies at the end of the day would result in positive macroeconomic impacts. But we should not forget that we are not alone, and we live in a global economy. And we must be aware that other countries, and in particular the States, and of course China, they are not somehow stopped there waiting for us to move. So all these kind of decisions must take that into account. And this job perspective that we're mentioning and actually reflect this change of industry, it's also extremely dangerous in this sense. But I agree with Patrick, it shouldn't stop us, so this idea. And that's not what I claim. What I claim is that when we make these kind of movements, we need to be aware of the systemic impacts that we are going to have. So when we make decisions like these, we need to look at macroeconomic impacts, as you are mentioning, and we are looking, for example, at perspectives like the tax returns. Let's imagine we have some issues, very practical ones. We have some countries which have a high tax level over oil products, for example. They must change these high tax levels. They need to have their return, how they are going to do it. So these kind of things must be considered before making the movements, just this. And so this is what I wanted to there is a kind of a picture that shows this carbon tunnel vision where you have this objective of reducing carbon emissions, which makes sense. But we need to look at the macroeconomic impacts. We need to look at the tax perspective. And of course, we need to look at people, just these. And we are actually have this problem of, again, not being alone. And what used to be a kind of a consensual vision that would come from the other side of the ocean is not coming anymore. And we don't know what's going to happen in the future. So we must make decisions that at the end of the day are resilient, not necessarily focusing on the day after only, but thinking in the long term.
Thank you. Patrick, lithium batteries are, I think, the most burning issue for European car industry. And it's becoming quite difficult to develop local supply chain. Any place where we find lots of lithium gets covered with environmental activists who block development of lithium mines and practically disable Europe getting sovereignty, strategic sovereignty of lithium supply chain. How do you think this could be solved?
Yeah, let me come back on the notion of sovereignty, which is, as you know, historically something important in France, starting with defense. You don't have sovereignty when somebody can block you to do something. So if we look at lithium, I'm not saying there is no sovereignty issues on batteries. I'm just starting from lithium. Lithium, you have lithium in many, many places in the world. It takes 3-4 years to set up lithium mines from when it's blended with water in some places, in some other places with rocks. In that case, it's more 5-6 years. So we don't necessarily need lithium in Europe. I hope we will. I really hope we will. There is 2-3 projects in France, one in Alsace, that's the same one basically in Germany on the other side of the frontier. There is another one with rocks somewhere. I really think, I hope there are many in Spain. There are some other in Serbia, if my memory is correct, and there is always environmentalist issues around it, so we need to deal with them. I hope we will be able to do it, but I would not say this is a sovereignty issue because we can still find lithium. The prices went down and they will continue. There will be some ups and downs, but basically there is lithium, a lot of lithium around the world, and this is in many different countries, so we won't be blocked buying lithium. So it's less a sovereignty issue than the second point, which is the know-how, how to build batteries and how to refine what we call PECAM, the cathode active materials and the precursor of these cathode active materials. This is a sovereignty issue. We need to be able to do that in Europe. Some companies, BASF can do that. Belgian company can do that too. But this is still small, and we need to partner with Chinese companies to have that on European soil. I think this is very important. The second point is the know-how, how to build batteries. We have seen with Northvolt that even though they were very well funded by Europe, but mainly by private financing, they failed. And they failed because this is a very complex process, and Asian companies have been working on that for 15 more years than European, and you don't catch up on a very complex process that quickly. So this is a big issue, and we need to find a way to solve that. This is really a sovereignty issue. Europe is pushing for more protection by the CO2 footprint and by a minimum local content. I think we need to continue on that. We need to support the existing plants without spending too much money on it, because if they made mistakes, they have to pay for it. The private companies have to pay for it. But also, and I think currently there is a big push on that. We need to really strongly increase R&D on the next battery technologies. So sodium-ion, lithium sulfur, zinc air for batteries for the grid, and so on. And I think this is a sovereignty issue. We have been stupid enough not to see the coming of electric cars and lithium-ion batteries. We don't need to do that a second time. We need to prepare for the next generations right now and catch up. And if we cannot catch up with our own companies, then we need to partner with Chinese. This is what China has been doing for half a century. Now they learned, and now they are ahead. So we also need to be modest enough, humble enough to be able also to collaborate with Chinese companies, as long as they come, make plants in Europe and accept some technology transfer, as we did with China for the last half century, basically.
I like your point very much. It's an important point. Charging infrastructure. Cars are parked 96% of time. 90% of drives are inside cities. So from the system point of view, it would make sense to have a slow, smart charger in every single parking place. But we are actually developing different strategy for charging. We have fast chargers in cities. Ingo, what do you think when this is going to change and go more to the every single place having a charger? I mean, European Commission was suggesting that 10 years ago. There was a proposal that every new parking place, 1/10 of them should have charger immediately, but car industry blocked that proposal.
I think our charging infrastructure is not that bad. When we look to the motorways nowadays, we always have fast charging in any place where we can stop. And according to my own experience, I almost never need to wait until I get a place to charge. And on motorways, I'm very happy that we have fast charging stations, because that's exactly the time going to the toilet, drinking coffee, and then continue driving. In cities, I don't see those fast charging stations, at least not in my environment.
50 kilowatt?
But 50 kilowatt AC, no car is using anymore 50 kilowatt AC. They
No, 50
typically
kilowatt
stop at
is
11
50 kilowatt is DC.
AC, and that is what we typically see in our cities. And typically nowadays they only provide 11 kilowatt AC charging. But I agree, even that is maybe too much when the car is just only parking. And then it is, I think we see progress. We have now pilot installation of those chargers that you can implement into the street, at those stones separating the street and the pedestrian areas. That develops quite well, because it's always also a problem how to give electricity to those parking places. It's a lot of infrastructure, cables needed to be laid, but I think there are solutions going. And when you are happy that you have your own house, I think then it's not a problem. There you always have sockets.
Okay. Reinhard, what do you think about hybrids? Hybrids look like a good solution for transition, with especially for people that were a little bit afraid of changing technology of driving. But then we see them after a few years completely collapsing. Norway doesn't buy hybrids anymore. We see that in other countries, that after maybe 5 years of hybrids market, now in China, hybrids market is also going down, and battery electric vehicles taking up. Hybrids are more expensive because you need to have two drivetrains. What do you think, what is the future of hybrids?
Nevin, I will answer this question a little bit later, but first I would like to enter a discussion with you. So what you discussed about cities and electric vehicles is, to my extent, not acceptable. Because in cities, as Vienna, as Munich, you actually do not need an own vehicle. You have a full infrastructure of public transport with electric vehicles. But the problem is, if you go to the countryside, in any county in Austria, Upper Austria, in the countryside, you do currently not even find a taxi, and it must not be an electric taxi. So most people who are really, let's say, fostering the transition are owning a battery electric vehicle far away from any city, and they do just charge it at home. Okay, and now to the hybrids. I think it is not fish, not meat. So if we want to get out of the ICE, I think the mild hybrids will not have a chance to survive. I think it's maybe for the transition period to the transition a proper solution, but as soon as the batteries of the electric vehicles become better and better, there is no more the need from my side for the backup system. But I also have to say that I'm not really the expert for this type of technology, and I have not really followed these developments in detail.
Okay, so I would like to open floor now for questions from general public. I see two questions there. Do we have a microphone? Keep your arms up. Okay, the third question is there. So, Peter, first the gentleman in the second row, that one, yes. Yeah. And then the gentleman behind.
Thank you.
We need no sound.
One? Yeah, it works. Yeah, thank you very much for interesting discussion. My name is Dmitry Bogdanov from LUT University. And I have a question. Why don't we talk about consumers? Finally, it's we the people who buy ICE cars from the market right now. BMW, Volkswagen cannot urge average citizen to buy ICE car instead of battery electric vehicle. So, and it's kind of simple to discuss policies, hard policies, or bans on certain technologies. But remember the time when battery electric vehicles were cool, like back in 2018, SDEWES in Palermo, I remember Professor Dujic came with Tesla from Zagreb all the way through Italy, and everyone was so interested in this. People would queue in line to have opportunity to sit in Tesla. People were ready to pay extra money to be able to drive electric vehicles. Now it's gone, but maybe we could think about some actions to recreate this momentum, make electric vehicles cool again. And it can be rather simple, let's say in the cities, make some free parking or discounted parking for electric vehicles, maybe free charging during peak hours of PV generation. It will help all the system, but also create some click in the head of consumer and make them interested in electric vehicles again. And it may not cost much for the system. Maybe it will not cost economy of owning this car for the user, but he will be interested. And there is another beauty of this, from my point of view. If it works, it can be much better than these hard policies for policymakers. Because hard policy, if people don't like it, may backfire during next election. But if you made different environment for EVs and consumers made this decision to switch from ICE to battery electric vehicles, then it will be harder to blame policymakers for that. So it could be a nice way out for policymakers as well. So what do you think about such a perspective?
Well, it is maybe Patrick or Paula, I don't know.
Yeah, I can say a few words about about it. The first thing is a lot of that exists today. I don't know the situation everywhere, but I'm in Paris, for example. I have an electric car, and I can park for free for 6 hours in on public streets. So, and of course, this helps. I would say today in a lot of companies, and I think this is a European statement, you can charge for free at work very often with an electric car. This is on the tax system and so on, at least in France, has been adapted to that so that there is no complication. So this exists. What is not available is cars at a low price. This is the big issue. And I can say the will to get one is President Macron in France launched, that was a promise for his election, what he called, like it's popularly, so it's leasing supported by the state for people with a lower revenue. And this was, he had, the first time he had done that, it was 2024, 30,000 cars went away in less than a week. And he's just launched on the 1st of October, the same system for 50,000 cars. Same thing, in 3 days this time, went away. So which means when the price is low or supported, customers want the cars. And I think the main problem now is car makers need to do more affordable cars, need to get economy of scale, reducing their cost, make more affordable cars and so on. This is what's missing now. And I think it's starting to happen. So I hope we will see the result at the end of this year and probably in 2026 as well.
There was a gentleman behind Dimitri, okay.
Yeah, Mano Hamilton-Jones from IEE Institute for Sustainable Technologies in Austria. I'd be interested to hear the panel's view on the question of whether policies that promote electric vehicles, particularly subsidy-based policies, are perpetuating an artificial competitiveness of individual automotives over collective transport options, public transport. Particularly in context, most cars are owned in cities, most cars are driven in cities, and most cars spend most of their time parked in cities. And all of those are cases where public transport would probably be the superior option in terms of environment and social aspects. Should we maybe be looking at making fossil cars more expensive rather than making electric cars cheaper or more attractive to own, and try and push people away from owning cars completely?
So that looks like
Thank you.
Yes?
At least I can give a short answer. I would say I fully agree with you. It is very in favor of the electric vehicles if you have higher registration fees for the conventional fossil ones. But I would like to address the example of Norway. So it's not my personal work, but it's the work of my colleague. And Norway has a step-by-step policy, let's say, to give the carrot or to give the stick. So some time ago, 10 years ago, you could...
Chinese policy, you need to win lottery to buy internal combustion engine cars in big cities. But Europe is moving towards additional taxation of internal combustion engine cars through ETS2, which is starting from 27. We had a question here, lady in green. Please introduce yourself.
Hello, this is Albana Kona. I am a scientific officer at the European Commission Joint Research Center in Ispra. It's very good to be here. Actually, it's food for thoughts, really, to come here in SDEWES. And I have a question for Professor Paula Ferreira. I would like to put it on a more positive note, the EU. I would say just transition worked well for cold regions. So through the emission trading scheme, we channeled a big chunk of funds coming from the emission trading scheme for helping regions to phase out coal and to transform labor, to help people to readjust to the new economy. Could it be also this case for transport? Also, the carbon adjustment mechanism is doing miracles, I think. And also, we are putting a benchmark. We are setting ourselves as a benchmark with the emission trading scheme. Now, China is repeating this scheme, so I would see it in more positive light.
Yeah, I fully agree with you. Of course, there is this positive vision, and I also agree that it is possible to change. I'm just saying that it should be done under a kind of a systemic perspective of understanding that each region is different from the other, as you were saying, and that's why there are these mechanisms from the European Union that help us a bit, or at least try to help us a bit on correcting this potential injustice that needs to be, this injustice need to be flagged before their existence to make sure that at the end of the day, we can solve them on time. And if you allow me an example that the other colleague mentioned about the public transportation is an example of this systemic vision that I think should be brought also for the transportation sector. It's not only about moving from combustion engines, internal combustion engines to electrical vehicles, is also changing the way of how we organize our transportation sector. For example, implementing better public transportation systems. So everything should be thought in a way of being considered together, and of course, allowing to take benefits or benefiting from these support schemes that exist and should be used in favor, again, to make sure that you have these cohesion policies that somehow, again, are the backbone of our European Union, and we should use them to make sure that actually they are well used and represent a way of this inclusiveness is ensured at the end of the day.
I think Peter had a question, and then, okay.
Just a short question. Peter Varbanov from SDEWES2025 University in Hungary. Do we really need a lot of lithium mining? And it has two aspects. One, what about sodium-based batteries? And second, what about recycling?
Well, that's a question probably for Patrick.
Yeah, I can answer that. So the sodium-ion batteries are currently, they were developed, and a lot of intellectual property is in France at the Université okay, I forgot but it's in France, but the main industrialization now is starting in China. Sodium-ion batteries, I think, will have an interesting future, but not all future of batteries, because they are very fast to recharge. You can basically recharge a battery, a full battery in 10 minutes, and probably with developments even faster. But their energy density is much lower than nickel, lithium, nickel, cobalt, magnesium batteries, and even below lithium phosphate, iron phosphate batteries. So that's the limiting factor. For cities, if cars were staying only in cities, that would be the best battery. And I think in regions like India or China, on the coast side of China, and basically in all big cities in India, people don't drive a lot of mileage for a day. Sodium-ion batteries are great for that, and that's where it's currently starting to develop. Now, recycling. Recycling, we didn't speak a lot about recycling. Recycling is very important. Technology exists in Europe. Many companies can do that. The problem today is there's very little to recycle because batteries' life is very long. So you only get for recycling two things: the cars that had accident and that damage the batteries, and then you need to recycle, reuse part of it and recycle the rest, but that's small. And the rest is coming from the scrap parts in the battery plants, so which don't reach the level of quality, so they need to be recycled. But this is small. That's why recycling for the moment is small. It will get big, I think. It will not get big, I think, before 2035, maybe 32, 33. That's when we will use it. And that's going to be part, but maybe at the beginning 5%, 10%, and probably when we will be full speed on electric cars in 2050, then it could be like 80 or 90% of the supply. If we still use lithium for batteries, if we still use nickel and cobalt and manganese or silicium, silicium nickel as well. So I think this is the answer. You need to be patient to see recycling supplying the battery plants.
We had a question here, Antonio.
Well, after the optimistic and positive note of the colleague, I want to bring my negative feeling about how this story is going to evolve. I want to start from the last of the questions you gave in your last slide. Can we get rid of populism? I think this is the big elephant in the room, because if I shared in my town an open questionnaire asking 10,000 people in which year they would fix the deadline for the production of traditional engines, most of the questioners will have the open answer, never. So this is a problem because we should face very relevant transitions which touch several levels, infrastructures and so on. So it will be very expensive to tackle this challenge. And I think the industry is not scared. The industry understands that in this moment the context conditions make the risk, and we have such structural weaknesses that make it impossible for them to win the challenge. So the problem, in my view, is how we take the second lesson from Mario Draghi report in our society. Because Draghi, this public feeling is based on a basic lie. Do nothing and nothing will happen. So Draghi said this is extremely false. Do nothing and in some years you will see enormous changes in wars. So I think it is extremely urgent also for the car industry. The car industry needs a clear set of rules, of course, financial support. All these conditions require preliminary public support. And no EU Commission, no public national government at this moment with this public opinion. Probably have the feeling of Italian public opinion, which is a bit below the average in some sense on EU scale. But I think this is a problem we should tackle very seriously to solve.
Ingo, maybe? Do you think you can?
I think it was not a question, it was a statement.
Yes. Okay.
But
yeah.
Definitely populism is a problem. Or more scientifically speaking, it's the use of narratives that small stories try to make policy or try to form the public opinion. And maybe that is something we also need to learn, not to destroy ideas, but to build ideas. I had this very sharp experience in energy sector in my country with the last government. They had a very good idea of supplying or making policy for new heating systems for houses, building completely of electric heat pumps. But then the opposition and some newspapers came up with the narrative, it will be forbidden to heat. So it will be forbidden to eat with gas, with oil, but it will not. But it was always the picture in mind of the people, we will have cold houses. And that destroyed the complete policy. And I think also we have good examples for positive narratives, and maybe that we should need and apply more often to influence more in the direction we need to go.
Okay, Birol.
This is Birol Kılkış from Ostim Technical University, Ankara, Turkey. I have a simple question as an engineer. The weight of the battery package. Considering that we replace the ICE, other mechanical parts, but still we add on some more battery weight, I am not quite sure at this moment whether it's a negative, less weight or plus weight, if it is a reduction in weight, that's fine. But if it is an addition of weight, then we have to also consider research on decreasing the weight of batteries. What is the latest proportion? I don't know. This is the question.
It's a significant issue, but on the other hand, electric car is 4 times more efficient. But maybe Patrick could comment on the battery weight. Is it going to get reduced?
It's slowly reducing, but it's still heavy. A 50 kilowatt hour battery is going to weigh today around 300 kilograms. So the weight for an electric car is not such a big issue for a very simple reason, is that when you brake, you recover most of, which is like close to 80%, 70 to 80%, the energy you spend to accelerate your car. So the weight is not a big issue. The big issue for an electric car is the wind resistance, what we call SCX. This is what is the big enemy for an electric car. The weight is a big enemy for a thermal car in a city, much less for an electric car. That's why the weight of a battery is not really a big issue. You need to build the car a little bit more resistant. So you probably add a little bit more than these 300 kilos. You save weight on the engine, on the tank, and so on. For a truck, it's the same. You can, with a big battery that will weigh like 3 to 4 tons, you will add roughly 2 tons on a truck. So that's more significant. But again, this is not an issue for braking, accelerating. It's an issue, the same issue as for thermal engine for the resistance to the wind. That's so. As Niven said, the energy performance of an electric car. So if you take the energy from the very beginning, it's at least 3 up to 4 times better than a thermal engine car. A little bit less for a truck because truck is more efficient.
Okay, maybe one more question. So I have 3 hands. Okay, we had one first. And maybe if it will be too very quick.
I will be very quick. I want to point out something that is not was commented before, and was the light electric vehicle. For example, there are plenty of internal combustion scooter, and now there are no in Italy or in Europe option fully electric. In my understanding, a fully electric scooter would be cheaper. So it's not only a matter of money; it's a matter of how people think, as Antonio said. So I want to comment about this point.
If you go to China, it's only electric.
Yeah. I was in Asia, there are plenty of
Southeast Asia,
scooters.
it's now getting mostly electric. Why not in Europe? Well, obviously, somebody is slowing it down. So maybe we can have time for another question. There was a gentleman on the left side. Oh, okay.
Hello, Philip Gradl from Aintech. There was a lot of discussion about the electric vehicles itself, but what's about charging? As far as I know, when I want to charge an electric vehicle, at least in Austria, I need multiple apps, and there are different tariff models. And this is only in Austria alone, and Austria is it's not a very large country. So if I want to drive over the border, I need maybe more apps or different apps, and I need different charging tariffs. And I think for consumers, this can be quite difficult or exhausting. So how can we fix this?
Well, I have Tesla. I have no such problem. You know, buy Tesla. Yeah, I fully agree with you. This is a problem, but it's being solved slowly. So there are now suppliers which can cover many different chargers. You get a membership card from a company that actually covers most of charges where you need it. There are many different such companies. So I think this is being solved, but too slow in my opinion. When I'm not driving Tesla, it's always an issue.
It's the American solution.
Yes. Yeah, we had one more question there, and then I closed the discussion.
Who was it?
Yeah.
Thank you for this great panel. My name is Stjepan Družinac from Faculty of Mechanical Engineering in Zagreb. I think it would be important to address the main concerns of battery electric vehicle opponents. Mainly they're thinking that EVs are hypocritical, that they promote clean energy, but then they are 2.5-ton monsters that use much CO2 when being produced. And I would like maybe to offer a solution, maybe, to like the manufacturers are now penalized for producing cars that emit more CO2 than baseline, to set a baseline for CO2 emissions during production of the said vehicles. To maybe that would incentivize them to make them more compact and lighter. Your thoughts about that?
Narratives. Ingo, would you comment or?
I can also on that, Niven.
Yeah, Patrick, please.
Yeah. So let's put the order of magnitudes on the table. A very good gasoline car on 200,000 kilometers is going to emit 20 tons of CO2. A bad car, very big car, gasoline and so on, is going to emit 40 to 50 tons of CO2 on 200,000 kilometers. To produce these cars, a medium car, you need 6 tons of CO2, whatever it's electric or thermal. On the electric one, you need to add the battery. On the battery, for a 50 to 60 kilowatt hours battery, which is like the medium size today in Europe, you will need 2 to 3 tons, depending on where it's made and how the mining is made. But this is an average. What we hope is to go down to, for 50 kilowatt hours, we hope to go down to 2 tons. So remember, 20 tons for a thermal car. For the electric car, you will have 6 tons for building the car. For building the electric car, you will have 6 tons plus 2 to 3 tons, so 8 to 9 tons. And then, depending on which electricity you will get, if it's in Germany, if it's at night, if it's in France, if it's in and so on, you will spend another 4, 5, 6 tons of CO2. In the case of France, rather 2 tons. So still, when you compare the thermal car and the electric car, the gap is very big, roughly 3 to 4 times less. And even with the average German electricity, but electric cars take most of the electricity at night, which is much better, it's still going to be around 2 times less or 1.5 times less than the thermal car. And the important point to keep in mind is electricity CO2 footprint is going down everywhere, in all countries, even China, even Poland, and of course Germany, and France is already very low, just like Sweden and Norway. So if the car, I was using figures of today, but if the car is going to live for 15 years, so in 15 years, believe me, the electricity in Germany, in Poland, in China, and so on, will be much better. And as a result, the overall comparison between thermal and electric, both today, is going to be even better than what I was just calculating for you.
Ingo, short.
My answer to that discussion is always that electric cars are part of the solution of the energy transition. And as far as we get for the energy transition, also the footprint of the battery pack gets lower, lower, and lower. So it's a win-win situation.
Yes.
Okay. I will close now floor for the questions, and I will ask panelists now to give a final sentence. How would you conclude your position? Who is going to start? Please.
I think most important is to provide reliable, long-term, predictable policies and other boundary conditions for all participants in the system. And maybe infrastructure should be treated preferably in Brussels because it's a cross-border issue.
Thank you. Ingo.
Let's act now. Let's go for that, what we know where we need to go. Not later, now.
Thank you. Paula.
Okay, I think I will try to answer the question. Yes, I think it is possible to have a future that is related with industry development, and we can be also inclusive and with social development.
Thank you, Paula. Patrick.
Yeah, I think it's a mandatory move. That's no question. It's going to be painful, so it needs support and creativity to make it happen. And we need volumes. We need cheaper cars, which will provide economies of scales, and then the circle, the virtuous circle can go on. And this is true for the car assembly, for the suppliers, and for upstream mining and so on, and for downstream the recycling as well. Thank you, Niven.
As a moderator, I think I could conclude that this panel was positive on transition. We can make it. Thank you.
Yes.
Thank you.
Thank you. Bye-bye.